organizing. On behalf of the organizing committee, it is my great pleasure to welcome you all to this conference. Today, I will be co-sharing the program with Dr. Aziz Islam, Vice Chair of the Research and Innovation Working Group. This conference is an annual event organized by the ISWA Young Professionals Group, aimed at providing a platform for young professionals in the waste sector worldwide to share their innovative ideas. Our aim is to foster networking and collaboration between young professionals and researchers in waste management, bridging the gap between academia and industry. The current environmental challenges and climate disasters we are facing worldwide have highlighted the urgent need for a transition to a circular economy and responsible waste management. As young professionals, we have a crucial role to play in driving this transition and shaping the future of the waste sector. This year, the conference will focus on the role of young professionals and showcase the work of ISWA YPG working groups. Join us for the afternoon session coordinated by Dr. Hani Jalalipur and learn more on the YPG activities, exciting news, upcoming events, and the highly anticipated launch of the YPG flagship project titled Call for Best Practices for Creating Zero Waste Communities. This is supported by Waste-Wise Cities, UN Habitat, and African Clean Cities platform. Don't miss out on this informative and inspiring session. We have received abstracts from researchers representing over 10 nationalities, and from this competitive selection, we have built an exciting program with 2 sessions. Our goal was to provide opportunities for as many speakers as possible to be part of this conference, organized by young professionals for young professionals. The best presenters will be recognized and awarded for their outstanding contributions. To all presenters, we wish you the best of luck. We are excited to hear more about your innovative ideas. I'm thrilled to announce that we have secured a scholarship for one winner to participate in the ISWA Swiss Winter School next year. This is an esteemed program on sustainability and waste management at the University of Texas, Arlington. We extend our gratitude to Professor Sahadat Hussein, the director of Swiss, for offering this prize. Additionally, one individual ISWA membership will be awarded for a year. Our program features more than 18 young talents from different backgrounds researching various topics related to the waste management. We are proud to host this conference, bringing together participants from different cultures, nationalities, and genders. This year, we also have the honor of hosting 2 distinguished speakers, Zoe Linkovich and Brenda Honey, who are renowned in their respective fields. They will share their expertise, experiences, and visionary perspectives. Please feel free to introduce yourself in the chat on the right side of your screen. We encourage you to actively engage with the speakers by sharing your comments and questions in the chat. Please don't forget to mention the speaker's name when addressing them. Unfortunately, it looks we're facing some technical issues. Mrs. Catalina Ospina, chair of the ISWA YPG, isn't able to be present at the moment. Hopefully, she can join us later at the dedicated YPG session. We'll make sure to share also a video of her welcome note presentation in the conference recording, so you won't miss anything out of the exciting content. Stay tuned for updates on our conference website. Once again, I wish you all an excellent conference filled with valuable insights, inspiring discussions, and meaningful connections. Thank you for joining us today. And to officially commence this impactful event, please, I ask everyone joining on Zoom to mute when joining. And I'm taking a great pleasure in introducing our first invited speaker, Zoe Linkovich. Zoe is a purpose-driven technical specialist and people person focused on global waste management, working professionally in sustainable resource management since 2002. Zoe has been an advisor to the UN, ISWA, municipalities, government agencies, recycling businesses, and community groups in the UK and internationally, with a special focus on countries in the Global South. Her work has been driving international attention to waste management for global development. Please join me in giving a warm welcome to Zoe. Zoe, the floor is yours.
Thank you, Amani. I've turned my camera on. Can you see me?
Yeah, we can perfectly see you. Thank you.
Super. Okay. Thank you very much for the invitation and the introduction to speak with you all today. I'm really excited to be here. I am Zoe Lenkovic. I'm a global waste management specialist and a former member of the ISWA YPG. And it's a privilege to be here to address you all at the start of this excellent conference. So what have I got to say? Firstly, I want to say congratulations to all of you. I'd like to congratulate you on making such a top career choice. Waste management is fast becoming one of the most valuable services of our time. Communities and high-level decision makers around the world are recognizing the importance of waste management for tackling the triple planetary crisis of climate change, nature loss, and pollution, and you are at the heart of these efforts. Waste management is an enabler of the circular economy and is a vital service for human and planetary health. Without waste management, people have no option other than to dump or burn their waste. And these daily activities poison drinking water, harm unborn children, and contribute to the melting of the ice caps. By turning waste into resource, our efforts result in huge positive impacts for current and future generations and the natural world we all share and depend upon. Waste management is a hugely diverse and expansive area. And what's exciting is that I've never known so much momentum in our sector as I see today. I've also never known so many passionate young people who genuinely want to make a positive impact be drawn to waste management. Our tribe is special, so let's continue to lift each other up. Some really exciting things are happening in the world of waste management at the moment, and over the course of this conference, we'll be hearing such a broad range of presentations. We're going to hear about protecting the environment from emissions and pollution from waste. That includes the impacts of open burning. So, let's think about it. Air quality determines whether a city is livable or not. It affects human health in so many ways and releases emissions that cause climate change both in the short and long term. So open burning needs to be eradicated, and the more we learn about it, the more likely we are to be able to change policy and get waste management pushed up that priority list. We're also going to be hearing about new ways to control emissions from waste in landfills, right? We'll be hearing about approaches for reducing methane emissions from rotting biodegradable waste, and also treating liquid leachate to prevent harm to drinking water and rivers and lakes, these aquatic ecosystems that so many of us depend upon. Looking at biodegradable waste management, first of all, we're going to be looking at composting. 95% of our food comes directly or indirectly from the soil, and yet soils all around the world are becoming degraded at an increasingly accelerating rate. So what we need to be able to do is get this food waste, we managed to get the food from agricultural areas into cities, but somehow it's really challenging to get the food waste back to agricultural land where it can be turned back into, it can really be turned into soil conditioner to help retain the excellent qualities of the soil that we all depend upon for our food. Okay, this seems to be such an enormous challenge and no one's quite cracked it yet, but maybe somebody here today will. Then we're going to be looking at biogas. I love biogas, it's super exciting. So biogas is where we take food waste or rot, you put it into a chamber with no oxygen, and it releases biogas, which we then capture and burn as a clean burning renewable fuel. So because we can make biogas anywhere where there's human settlements, it means that we can really use it to tackle fuel poverty. We can create reliable, renewable and free energy wherever we need to. Also, at the same time, by dealing with food waste and preventing methane emissions that are causing climate change. And what's best is that biogas is a great opportunity for enterprise. So do look into this. If this isn't your area, I really recommend it as a highlight. The final way that we're going to be looking at treating biodegradable waste is with black soldier fly larvae. Many of you probably haven't heard of this yet, but it's basically you get your food waste, flies feed on it, they lay their eggs, they create larvae like maggots, and those maggots or larvae can then be dried and used to feed animals all year round. Great for livestock, and also, you know, this means we can feed livestock without the need to chop down huge swathes of forest to grow soy. Okay, so I want you to be thinking about how everything's interconnected, really, because you know, we live in a system and we can't be looking at things in silos. Okay, so next up, recycling. Got 4 really interesting talks on recycling, or different areas that we're going to be looking at. First of all, solar panels, right? So in our shift to renewable energies, again connected to climate change, we're of course generating new waste streams. Now, solar panels have a lifetime of about 10 to 15 years, maybe a little longer with reuse markets in Africa and elsewhere. But it's one of those new waste streams that's going to grow and grow and grow. So it's a really hot topic, and I'm really delighted to see it being featured in this conference. Speaking of hot topics, we're also going to be hearing about textiles. Oh, fast fashion, poor quality clothing, polyester. You know, a bomber jacket with a zip and a bit of padding could have 24 different kinds of plastic in it. You know, how do we deal with this as a waste stream? And there's new regulations emerging to try to stem the tide of textile waste. So it's a really interesting time. And, you know, I'm really looking forward to that talk. Then plastic waste. I mean, you know, we hear so much about it, and there's so much of it, and so many different types of polymers. You know, of course, it's really useful as a low weight, low cost, durable material, but then what? So we're going to be hearing about how plastic's being recycled to be used in roads. But I also want you to think about, you know, the Global Plastics Treaty is currently being negotiated. So, you know, it'd be great for you to be thinking about how, you know, what changes could that bring about? You know, it could bring about major, massive change, or it could bring about negligible change. So let us think about that, you know, as we go through the day. The final recycling area that we're going to be looking at is construction and demolition waste. Now, cement is one of the most carbon intensive products that we use, plus the sand, plus the water. You know, construction is really carbon intensive. But then the waste from building sites and demolition sites is often just dumped, or at best used for landfill cover. You know, we can do better. It's such a huge waste of resources. This is going to be a really exciting talk. And the final set of talks I'm going to discuss is on the different perspectives in waste management, okay? So first of all, we're going to hear about waste pickers, this informal waste sector, that, you know, waste pickers really are the backbone of the circular economy. They're the ones collecting the materials, getting them back into those value chains so that we can recycle them and reuse them and prevent them from causing pollution. So really, really important that we're all mindful of this, you know, millions of people that work to collect these materials that we can then use in a circular economy. We're also going to hear about changing attitudes and behaviours in cities and on university campuses. And we're going to hear about shifting to a circular economy in Lagos, Nigeria, which is the fastest growing city in the world, but with a real lack of waste management. You know, never has the need been greater to see waste as a resource and reduce the amount of stuff we simply throw away. Now, before I finish, I'm going to have a quick sip of water. Excuse me. And I'd like to offer 5 suggestions that will help you in your careers. Number 1, stay curious. Read widely so that you can understand how global events shape waste generation. Learn about innovations and developments so that you can stay ahead of the game. You know, we were talking about solar panels earlier. What are going to be the new waste streams of the future? You know, you're all clearly keen. You're all here on a Saturday to share your knowledge and listen to others, and that's super cool. So number 2, help each other. We're all on the same side, and there's more than enough waste for all of us. The world needs more waste managers, so let's be generous with our knowledge and skills and use our positive energy to amplify one another's impact. Number 3, be open to trying new things. So I've worked in the public, private, academic and non-profit sectors now. Through the years, I've learned a lot about the different responsibilities, perspectives and cultures of these different workplaces. I liked some of it. I learned from all of it. Most importantly, I learned a lot about myself, which leads me on to my next point. Know your value and your values. Know where you will be willing to compromise and where your red lines are. Okay, over the years, I've gained knowledge and understanding, and that's led me to be willing to compromise more on some things and less on others. Knowing yourself and your value is the journey of a lifetime. If you don't feel like your current workplace is the place where you're going to make your mark on the world, that's okay, you have time. Learn what you can, where you are, and as you get to know yourself better, you'll be able to move more and more into your perfect niche, where your experience is valued, where your voice is heard, and where you can make the impact that you want to make. Number 5, lead. You don't need to be old to be a leader. Leaders come in all shapes and sizes. It's about how you treat others, how you inspire them, how you set an example. Although you're at the start of your careers, there are plenty of younger people coming up behind you, and they will be looking to you for advice, support, and leadership. So please go ahead and be the leaders that you want to see in the world. Look, more and more businesses and organizations are understanding that people are at the heart of any successful waste management initiative. Whether they are the people in the boardroom making investment decisions, or in the laboratory testing innovations, crunching data on spreadsheets, changing behaviours to keep cities clean, or at waste depots, or collecting waste, or simply at home choosing what to do with their waste, it's all about people. And that's all of you here today, and everyone you interact with through your jobs and your lives. So enjoy your conference, network with each other, learn from each other, be open with one another. Our tribe of waste managers is very special. So thank you all for your efforts, and I wish you a fantastic conference and an exciting and fulfilling career. Thank you.
Thank you so much, Zoe, for your inspiring and motivational speech. It was a great pleasure to have you with us today and learn more from your experience in life and your past experience with ISWA. Your inspiring keynote has set the stage of the commencement for this conference. Thank you so much, Zoe. We greatly appreciate your time. If you can stay a bit longer with us to answer some of the questions or comments from the audience in the chats here on Zoom and also on YouTube, on the YouTube link. Thank you so much, Zoe. We can now start with the first session. This session includes 9 presentations, 8 minutes each. You can submit text questions to the presenters by typing them into the chat box. Presenters will answer them on the same chat panel. Please mention your name and state to which presenter you would like to forward your question. We kindly ask all presenters to remain until the end of their session and to respond to the audience. Now let's start with the first presentation. Ladies and gentlemen, it is my pleasure to introduce our first presenter, Johnny Igdayes. His presentation is titled A SWOT Analysis for Using Anaerobic Digestion for the Treatment of Organic Waste. Johnny is from IDOM Consulting and Engineering in Spain, and he is presenting the research that he conducted at the National School of War and Environment of Strasbourg, France. Johnny, the floor is yours.
Hello, good morning, everyone. I hope that you can see my screen and that you can hear me well.
Yeah, we can perfectly see you.
Okay, perfect. So as our colleague, Dr. Amani mentioned, I'm going to be presenting a brief introduction about the study I performed during my studies in France about AD and about the SWOT analysis about AD. So it's going to be, my agenda for the day is going to be a brief introduction about AD and a quick SWOT introduction. SWOT means strength, weaknesses, opportunities, and threats. So what is AD? AD is is a one common treatment currently used for treatment of organic waste. We can have a mix of a mix and a variety of waste used within this treatment. What happens in the process of AD is that we need to work in an anaerobic environment in a tank usually called digester. It has different forms, different shapes, and usually produces two products, which is the digestate and the biogas. The digestate can be later, after certain treatment, can be later used as a fertilizer similar to compost, and can also, depending on the country, of course. And the biogas has multiple usage depending on if you want to convert it to biomethane. And as all of you know, both of them can be used to generate power, electricity, or other kind of other kind of forms as such as heat. It occurs. So how did we discover it? Actually, we have two kinds, which is the naturally occurring anaerobic digestion. It usually occurs in the bottom of rivers, swamps, rice fields without any human intervention. And the second one is with the human intervention, where we actually create an anaerobic environment for the treatment of organic waste. This process is very commonly used in Germany, Belgium, and USA. So what is the main strengths of AD is that it's very flexible. So we have different kind of operation temperature. We can either operate at a lower range, which is called mesophilic, or at a higher range called thermophilic. And the second point, which makes it more flexible, is the amount of volatile solid of all of the inputs. So we have different ranges, usually called wet and dry, and whatever lies in between can be modified with the addition of water. So if I'm a bit more above the wet range, I can add a little bit of water to make it wet. A bit above the high end of the dry range, I can add more water to make it to fall within the dry range. Why is this? Why is it better to add water and enter the correct range? Because this will allow me to ensure optimum operation condition for the degradation of material within the digestion. So, what is the weakness? What is the weaknesses of AD is that we need certain criteria and certain operation conditions to ensure that this functions well. One of the most common and well-known is that we need a big surface area or a big surfaces to actually put in place this treatment, such as the digester, the gas collection system, the composting for the digestate later. And all of this would require a certain area, which is, at least depending on the countries and how we do the detailed design of the process, but usually it's around 3,000 square meters. Similar to the surface area, for the feedstock to be for the operation to be correctly used, we need a certain amount of waste to be used as feedstock, and under this amount, usually around 25,000 to 30,000 tons per year, the AD itself, because of all of the materials and all of the processes it needs after it, would not be feasible and rentable in terms of economically feasible. And also, an important factor to take into account is the social acceptability, which is a very well-known topic, not in my backyard. So certain areas might refuse totally to have this kind of processes next to their houses. And finally, the comparison to other possible treatment processes. For example, sometimes composting might be cheaper in a country, sometimes incineration might be cheaper, but we need to do the economic comparability with other possible treatment solution for organic waste. Moving on to the opportunities, as I mentioned briefly in the introduction, AD allows a creation of synergies between multiple feedstock. It's not a uniflow. It's not like we can only use wastewater, we can only use manure. AD allows you to mix between inputs, and this is a very good opportunity for us to create a synergy between different waste generators, such as organic waste, manure, crops, fruits and vegetables, wastewater, and all of this mix needs to be well studied to ensure that our volatile solids amount is within the correct range. Moving on to the threats. this is directly linked to all of what I mentioned previously. Since our AD is the design of our AD is directly linked to the inputs, we need to be very careful about the impact of quantities I have and the fluctuation of quantities that I might have during the year. And I need to ensure that the quantities I receive are more or less within a certain range. Because if the quantities vary a lot during the year, my digester might be underutilized or over-designed. And the other impact we need to look at within the threats is the impact of quality. The inputs are directly linked to the production of biogas. Therefore, I need to ensure that the quantity of biogas I'm producing is constant over the year to ensure the profitability of the project and to ensure that I am providing for the offtake of the biogas, I'm being able to provide for the off-taker enough quantities. Moving on to the conclusion, and here I need to shed the light on two important also topics that can be looked at and should be looked at when looking at AD is first the regulatory framework, because sometimes, as most of you know, some countries are have more regulatory restrictions on the use of the final products. They might require further treatments. They might require further processes. They might restrict the use of digestate, for example. And this needs to be looked at because it can directly affect our business plan and project viability. I would like to thank you all for listening to my brief SWOT analysis about AD, and I'm ready to hear any question if anyone would like to ask anything.
Thank you so much, Johnny, for your insightful presentation and all the information you have provided. Please stay with us in the session to answer any questions from the audience. Now, continuing with our session, it is my pleasure to introduce our next presenter, Maud Salim Mahtab from India. His presentation titled Iron-Rich Sludge Reuse for Landfill Leachate Treatment, a Sustainable Waste Management Strategy. Maud works at the DH College of Engineering and Technology, Aligarh Muslim University. Maud, the floor is yours. Please share your screen.
Yes, thank you very much. I'm sharing my screen. Is it visible?
Yeah, we can see it. Thank you.
Okay. So thank you very much for introducing me. And the topic of my presentation is iron-rich sludge reuse for landfill leachate treatment. Actually, as an environmentalist, wastewater treatment and sludge management is one of the most challenging tasks because the treatment processes generates a huge amount of sludge when we talk about the biological process and sometimes chemical treatment also. So how to manage such sludge, that is very, very important. So we have targeted here in this particular work how to reuse that sludge in a sustainable way for further utilization and management. So the contents of my presentation is that introduction. So actually the huge amount of sludge production in particularly wastewater accounts up to 30 to 60% of the treatment overall operating cost. Among the different categories of sludge, if we talk about the advanced oxidation process, that is one of the chemical treatment, advanced wastewater treatment for complex wastewater like landfill leachate. So the iron-rich sludge is one of the category in which the iron content is more. So rather than just direct disposal, the reusability study were evaluated for leachate treatment. Because one of the major drawback in the Fenton process is that the huge amount of sludge production. Therefore, developing innovative strategies for its management, it is very important to protect the environment and ultimately making the process more efficient. The primary purpose is its reusability for leachate treatment. So I have adopted the materials and methods, and in which the first we have characterized the landfill leachate, in which the high COD around 4,500 we have obtained, and the low COD content and the bioavailability around 0.22. That shows that the biological treatment for such type of complex wastewater is not suitable technique. So among them, advanced oxidation process is a very effective method, but the how to manage such waste. So rather than addition of chemicals for the treatment, because it is a costly step and addition of more chemicals, it's not a good solution for practical scale. So we have used that waste material as a value-added product. So utilize that present iron in itself already around 200 milligram per liter, and we have checked that around COD removal around 60% and more obtained for particular operational conditions, and also color removal and TDS also. So these are the procedures that adopted. That first we have collected land featured, and then we utilized the Fenton process, and whatever the sludge generated, we collected that sludge. From figure 2, you can see here that the sludge in figure 4, it's showing that the high iron content. The color itself showing that the brownish color, and the landfill leachate is blackish. You can see that the complex variability of varieties of contaminants present in landfill leachate, because different from sewage and other industrial wastewater. So the challenge related to the leachate treatment is complex at least, and the conventional jar test apparatus we have utilized in order to provide the proper coagulation and flocculation and mixing time properly to optimize the results. And also we have used that particular sludge reuse with pH adjustment and without pH adjustment. The results obtained because the DOE experiment condition, we have used the design of experiment software, that is because the one factor at a time analysis is time consuming, and sometimes the interactive effects we overlook. So rather than making one variable approach, we use that design of experiment software, and in which the central composite design utilized for the designing of the experiment and optimization condition. The total 3 factors we have used. pH, we have changes the pH value, sludge volume we have utilized, and reaction time. And the target response, particularly COD, main target, and the color and the total suspended solids were the second targets. In stage 1, we obtained that around 22% COD removal without addition of any external chemical, just by reusing the sludge that is generated from the Fenton based DOP, because the iron rich content present and the organics through the Fenton and Fenton like process changes the procedure of hydroxyl radical and degradation of organics. If the amount of the oxidant and the iron present up to optimized dosage, then further mineralization will also be possible. The observed values confirm that sludge reuse pH dependency, because without pH adjustment, we obtain only 22% COD, and by changing pH up to acidic condition, we obtain better results. The 3D surface plots shows that how the 2 parameter at the same time, sludge volume and reaction time, and the third, that is pH on the variable side, making the interactive effect for COD removal, and around 22% removal. In another case, that is stage 2, the maximum COD removal 62% around we obtained at pH 3.6. And also we gone through the analysis for fit statistics of the response analysis, confirmed that the excellent result in the actual predicted values and the experimental values with R square more than 0.9. The model F value confirmed that the suggested model is significant, and the RSM summary further confirmed that the close agreement between adjusted and predicted R square with less than 0.2. The adequate precision, that is the signal to noise ratio, that is desirable when its value is more than 4. So in our case, we obtained that value 19.196 and suggested that signal is acceptable. This model can be used to navigate the design space. And the analysis confirmed that the independent factors significantly impact the COD removal. We can increase the sludge volume. We can maintain the optimized condition in order to improve the COD removal. But there are certain optimized conditions. It is not like that just by increasing the chemicals, similarly increasing the sludge volume, we can increase the organic pollutants removal. So there are certain optimization conditions. And at this, we have targeted the optimized condition, and we are able to achieve that value around 62%. And at that value, total suspended solid more than 95%, and color removal more than 80% was obtained at the reaction time of 48 minutes of with 84 ml sludge reused around pH 3.6. Also, we obtained the synergistic effect of the sludge reuse system, like coagulation, absorption, and oxidation by non-regenerated fronton sludge reuse without further pretreatment, because the reported literatures confirmed that the further pretreatment will also make the process complex and also the costly process. So we have targeted how to make that process environmental friendly as well as cost effective, and we obtained a satisfactory result for that. And also, we have gone through the toxicity analysis of the sludge. So in regard to the different heavy metals, we find out that the reduction in other heavy metals and also the iron also utilized in the different cycles. So we have gone for 4 cycles, and also reduction of the cycle iron and other heavy metals is taking place. So confirm that the toxicity also reduced. So it is a good alternative to reuse that iron-rich sludge generated from the fronton-based advanced oxidation process rather than just direct disposal, because the direct disposal account for disposal issues also and the sludge handling cost also. The role of leachate characteristics also influencing factor. We obtained that the humic substance present in the leachate can improve the iron +3 and iron +2 cycle. That is very, very important, because the catalyst reusability are main mechanism and driving force for such type of process. The current study, I hope, will provide new insight regarding handling iron-rich sludge in an expensively and environmental safe manner. It therefore offers most recent innovation waste transformation technology into value-added product that could effectively utilize for complex wastewater treatment, for other industrial effluent, and also landfill leachate, maybe stabilized leachate or old leachate. And it will significantly reduce the production of unwanted toxic ferric waste and total cost of the treatment process. These are the references I utilized and some papers published through that. And thank you very much for your attention.
Thank you so much, Maud, for your informative presentation and very well presented results. Now, as a reminder to the audience, you can submit questions or comments through the chat panel and address them to the specific speaker. Moving now to the third presentation, it is my pleasure to introduce Amaya Garcia Tabar from Spain. Amaya will be sharing her presentation titled Optimization of the Conditions for Digestate Stabilization by Composting in an Industrial Plant. Amaya works at the IDOM Consulting and Engineering Company. Amaya, the floor is yours.
Okay, can you see my screen and can you hear me?
Yes, perfect.
Okay, thank you. Good morning to all of you. I'm here to present an R&D project that we carried out together with Garbiker Waste Management Company. The title of this study is Optimization of the Conditions for Digestate Stabilization by Composting in an Industrial Plant. Given the energy needs of the world nowadays and the boom in existing green energy, there is a recent trend towards the management of organic waste through anaerobic digestion. As Yoni told us before, anaerobic digestion is a biological process that is widely used as technology dedicated to convert various organic waste into bioenergy. In addition to this bioenergy production, AD produces large quantities of solid byproducts known as digestate. This digestate is rich in nutrients, making it potential substitute for chemical fertilizers in agriculture. It is traditionally being used directly in agricultural applications without any treatment and causing potential health and environmental hazards. These make post-treatment necessary before land application, and composting is considered a good option for this post-treatment. And there are studies that have observed difficulties in composting digestate to reach the thermophilic phase, to avoid higher ammonia emissions, and to have a low quality compost production. So these drawbacks make composting of digestate different from typical composting of other organic waste. Therefore, this study aims to answer the following question. can we get a good fertilizer by composting digestate? We will see during the presentation. So here we have two compostability tests that we carried out during the study. In the first one, various mixing ratios were tested in order to answer the following two questions. What is the optimal mixture bulking agent and digestate? Does the material ferment? In order to answer these two questions, three types of mixing ratios between bulking agent and digestate were tested. These were kept for 2 weeks in fermentation tunnels and for 3 weeks in maturation piles, and we turn it every week. In the second test, various bulking agents were tested in order to answer the following three questions that we have there. Which is the optimal bulking agent? Does the bulking agent affect the fermentation? And what fermentation type is required? So to answer these three questions, three types of bulking agents were tested into mixing ratios. The three bulking agents that we use were the newly available bulking agent, the recirculated bulking agent that they have in the composting plant, and those reject and discard that come from the first test. The raw materials and the analysis used in the experiment are shown in this slide. We had two feedstock, and the first one was the digestate from nearby mesophilic anaerobic digestion plant, this one, and the bulking agent commonly used in the composting plant is this one, which is pranine and garden waste. It should be noted that this bulking agent was found to contain a large amount of green matter as grass. As analysis and control parameters, the following were measured. First, continuous and punctual temperature measurement, punctual measurement of humidity, we did it by hand, visual inspection, and laboratory analysis. Here we check the maturity of the compost by rotagrade method, and nutrient and heavy metal content. Here are the temperature results obtained during the first test on mixing ratios. We can conclude that all experiment units were active during the first week of the process, reaching 70 degrees for a sufficient time in accordance with European regulations, and taking into account the bulking agent used with a high contribution of green matter. The activity in the mixture could be due to this matter. Therefore, the second test was focused in this assessment. And the need to keep the material for more than 2 weeks in the fermentation phase was observed. As you can see in the graph, in the second week, it has a very, very high temperature, so we will need another week at least. This slide introduces the visual inspection and laboratory analysis obtained in the first test. As a conclusion for the visual inspection of this test, we can say that the 3:1 and 4:1 mixtures are the best performers. This is because in the experimental unit of 2:1, we have here a pasty texture and another of ammonia and putrefaction were found during the first weeks, reflecting the loss of nutrients to volatilization and possible anaerobiosis. In any case, all mixtures were suitable for composting. This is confirmed by the laboratory analysis, which show here a lower content of nutrients in the 2:1 mixture. And here we have the results for the temperature for the second test. And we can conclude that the mixture made with a tanner obtained better results in terms of the structure than those made in the first test using a solvent. A decrease in activity is observed in those mixtures that do not contain the bulking agent, probably due to the lower presence of green matter or grass. In those mixtures containing the usual bulking agent, it is necessary to increase the period of fermentation to 3 phases. As you can see here, we need at least 3 weeks to have a good temperature to go to the maturity phase. According to the results of compost quality for the final product obtained in both tests, it can be said that all composts are suitable for sale in European level, but they obtain a big quality due to the heavy metals they contain. However, as we can see in this graph that we have here, It has been proven that this content comes from the bio-waste used for the anaerobic digestion. Since the content decreases here and here, decreases as the amount of bulking agent increases. And in other compost obtained with other bio-waste from other location here, the concentration of the heavy metal was lower. For conclusions that we obtained in this test, for the first test, as I told you before, all the mixtures are active during the first week of the process, reaching 70 degrees for enough of time. More than 2 weeks seems to be needed for finish the fermentation phase in most of the cases. The 3-to-1 and 4-to-1 mixtures are the best performers. The extra addition of bulking agent retains nitrogen content in the raw material. All mixtures obtain big quality results due to the heavy metals. And taking into account the bulking agent that we use with a high contribution of green matter, the activity in the mixture could be due to this matter. So we need to check how many weeks do we need for the fermentation phase. And at least all mixtures are suitable for composting in both cases, in both tests. For the second test, we concluded that mixture made with a turner obtained better result in terms of structure than those made in the first test using shovel. A decrease in activity is observed in those mixtures that do not contain the usual bulking agent due to the lower presence of green matter. In those mixtures containing regular bulking agent, we will need more time for fermentation phase, at least 3 weeks. And all mixtures, as I told you in the first test, were good for composting, but they had a big quality result. Thank you to all of you. Thank you for the attention. And here you have my contact details. If you have any question, you can contact me, of course.
Thank you so much, Amaya, for your informative presentation and presenting the very promising results.
Thank you, Amani.
Thank you. Now, proceeding further with our session, it is my pleasure to introduce Raghur Das from India. Raghuvir will be presenting their research on a techno-economic assessment for recycling of solar photovoltaic panels in India. He works at the Sustainable Technologies Team, South Pole. Raghuvir, the floor is yours.
Thank you so much, Dr. Malouf. It's a pleasure to speak to the audience. My name is Raghav. I am currently part of the technical team here at South Pole. We develop carbon credit projects, and I have a background in public policy, and I'm a passionate environmentalist. So I combined my passions for renewable energy and waste management and resource recovery and condensed it into my research on a techno-commercial analysis of recycling of solar panels in India. This is sort of an industry-focused, project implementation-focused research study on while we have completely established the relevance and importance of clean renewable energy, especially in India, where we still have issues with our power availability, yet we have so much land available where we can install clean renewable energy like solar, wind, etc., and also other innovations. Now, to start off this particular conversation, what I wanted to sort of submit to the audience was, after my presentation, you will learn how we can sort of price the recycling of solar panels, what is the importance of it, how much waste are we generating, and what are the technologies that are currently available in the world. So solar is an extremely resilient, passive, does not require a lot of maintenance. And similar to what Zoe was mentioning, solar panels on average last 20 years, and we're expecting them to last about 25 years with a slight degradation in performance. So solar is decentral, solar does not make any noise, does not generates jobs wherever it goes, and is very easy to produce and scale up relative to, say, a thermal power plant or a nuclear power plant or even a wind power plant. Especially in times of disaster relief, you can very quickly set up solar panels and get started right away. But Now that we know it's easy to implement, but what about the end of life recovery of these panels? Is solar a silver bullet? No, it is not. It is part of a bouquet of different strategies one takes to decarbonize one's industrial sector, to sort of get clean energy in remote areas where this is not difficult, but it has to be done with a cradle to cradle, a circular economy perspective, because of the sheer quantity of waste that we're about to see in the coming 5 to 10 years. So as per IRENA's latest estimates, we are going to get in excess of 75 million tons of solar panels as waste. And in my research, what I found was the panels which are currently coming out, nobody knows what to do with them. So what they tend to do, especially in India and other countries, is simply bury them. While countries such as Germany, US, and China and India are rapidly installing solar and gaining ground on how quickly they're able to deploy these technologies and manufacture them at very large scales. So much so that solar power in India used to cost about 20 rupees in the early 2000s, and now, as for the latest auctions of energy, of solar energy in India, it is less than 2 rupees. So even with storage included, the price has fallen by more than 90% based on the animal spirits of the Indian economy and how quickly people are able to scale up, manufacture, install these, and commission these projects. So here, what I'm sort of showing is the estimated end of life panels that people are expecting to come out. So it's sort of correlated to the quantity that went in. As you can see, China, US, India, and among other countries who are rapidly sort of installing will also need to sort of start questioning, what do we do to make best use of the situation to recover the waste, to recover the resources back? Now, a key part of my research was also to sort of understand the kind of innovation or the kind of research that people are thinking. This patent analysis, I learned, is a great way of trying to understand what kind of innovation is going on, the kind of questions people are asking, what kind of problems are people facing when they are attempting to set up industries or set up pilot projects on how to execute a certain type of project. And so in this particular case, it's the breaking up and recycling of the constituent parts of a solar panel. That I'll just show you what does it typically look like, what are the different layers involved, and where do we actually face problems. Like a solar panel is so well made, it lasts 25 years with barely any drop in performance over its 25-year lifespan. What could possibly be the issue in such a well-designed, well-made product that it becomes difficult to sort of break it apart? So moving on. This is an exploded view of what a typical silicon-based solar panel tends to look like. So you have a top layer of glass, you have a frame that is typically made out of aluminum, you have the actual silicon upon which the solar rays fall and where Einstein's photoelectric effect takes place, and of course the backsheet at the junction box. And while I'm not including the balancer system or basically the wires, the cabling, the inverters, and the actual metal stand because they have their own markets, this sort of shows you that there is so much potential for resource recovery here because glass is very easy. It's infinitely recyclable. Aluminum, the best way to make aluminum is by recycling it. So you know there's a market for this. Silicon, people typically tend to shudder because to make solar grade silicon, you need to sort of take a specialized type of sand, make ingots out of it by melting it, and then they slice it really thinly, similar to how a regular computer chip is made. But what happens is this tends to be the part that it tends to be a little tricky, that how do we sort of process end of life silicon in such a way that the powder can be recycled again. And of course, within a solar panel, by weight, you'll have approximately about 0.5% of silver and other highly conductive materials. That is how the wires and the silicon bits are connected together in series and in parallel inside the electrical circuits of the actual solar panel. But by the economic cost, it accounts for more than 15% of the cost of a solar panel. So there is a substantial reward that awaits anyone who invests in the recycling of these panels, but at scale. But because this product is so well made for all these different layers that you see here, the aluminum, the glass, the encapsulant, they need to be encapsulated in a specific type of plastic material that is referred to here as the encapsulate. And this is where it gets really challenging. It is sealed hermetically so that water, dust, sand cannot enter. But this encapsulated material is so well made that it is very difficult to sort of take it apart unless through incineration or pyrolysis means, which tends to be a waste of energy. So right here, we see a great potential to incentivize the development of encapsulated material, which can be easily or relatively easily removed post the end of life of a well-made solar panel. So now that we know where the challenges arise, what I wanted to sort of try to understand was, how can the levelized cost of electricity from such a solar farm be designed so that we can include the cost of solar, the recycling into the cost of the solar panel itself, or the power that is generated from the solar farm. Now, what tends to happen in all your auctions and all your solar power bidding is such as the power is bid on the levelized cost of electricity or the levelized cost of generation, wherein because once you pay the initial cost of a solar panel, for the next 25 years, you essentially do not need to pay to put any input materials. It will just sit there quietly, absorb the sun's rays and generate electricity. So to divide the cost over the life cycle of 25 years with a sufficiently profitable internal rate of return and a discounted cash flow, the formula that they tend to use is called the levelized cost, wherein instead of paying upfront $100 for 1 unit of power, you sort of break the $100 per unit of power over the lifespan of 25 years of the panel. So in essence, the $100 per year becomes $4 per year for the next 25 years. So this is what the formula looks like. This is what I use to sort of approach my designing of a project, which can factor in the cost of the solar panel recycling. So on the left-hand side, you basically see so I created a theoretical project. This is not what actual projects cost, but for the purpose of my research for this audience, I designed a project based on the most accurate and the most precise cost headers that industry experts typically use, especially in India, because I interviewed a couple of people and I got this from the Karnataka Energy Regulatory Authority's website itself. And on the right-hand side, the table, what it shows you is, if I were to design a theoretical factory which recycles these panels at a distance of 100 kilometers from a bunch of very large solar farms, and at rates determined by the Indian railway system, which also carries in bulk the any cargo consignment that you may tend to share it. And typically for 1 megawatt worth of solar panels, it's 75 tons of solar panels are required. So that's how much it weighs. If you go to a solar farm, you look at all the solar panels, you weigh it, it'll come to about 75 tons or thereabouts, including the balancer system. All these different materials, the metals, the copper wiring, the solar silicon, the glass, the aluminum frame, all of these have an afterlife market. They all have end-of-life destinations where people tend to take these materials, grind them into a fine powder or paste, and heat them up and recycle them and sell them again. So this is a very common system that is implemented, and this is what I used based on the latest figures that I had in my possession. Now here, what I've done here is present my calculations for the levelized cost of electricity based on calculating it on two cases. So the first the left-hand side Excel IRR sheet is basically the baseline scenario without any recycling included. And on the right-hand side, this is post the inclusion of the cost of recycling within the panels. And if you see row 32 of both these sheets, you will see that there is a very small premium that you have to pay per unit of electricity generated. In fact, it is less than 10% of the overall cost of 1 unit of electricity. So if your cost of electricity in India currently, which hovers around 2 rupees, which is about 2 US cents, the cost of recycling would essentially be approximately 20 paise or 25 paise, or about 10 to 15% tops. And this is a very affordable rate for any power player to pass on to the customer, because anyways, they will pass it on to the final consumer, which is either the government or to a private consumer. But this is a sufficiently good a margin for them to collect the money in an escrow account, let that money grow. And once the panels start coming out, they can then install a project where they can pay for the cost of transportation of the solar panels that come out, take it to a factory where you will have new employment generated by having people break the panels up, take off each component separately, process it for recycling, and then actually recycle and sell the material back into your economy, thereby making a very end-to-end loop for and make a very strong circular economy case. So not only is solar a very strong component in your bouquet of strategies to combat climate change, deindustrialize, generate clean electricity, but if you were to recycle it, you wouldn't even need to mine new materials or or you would not need to create new mining sites or industrial sites to manufacture. You can actually make an end-to-end implementable system, provided you provide the right kind of incentives and the right kind of guidance to your industry. Now, my recommendations include, as part of my conclusion, that please identify correctly the responsibility of your industry through legislation and regulation. So if you look at Europe and Germany have the WEED law, which is the Waste, Electronics and Disposable Act in of course, German. And in India, under the e-waste rules of 2018, it is the industry that is responsible for the end disposal of these products. Now, so the rules in India are fairly clearly defined, but industry still does not know how do we sort of actually execute this. So what they tend to do is they either bury it, or as per my latest update here in India, there's very small scale pilot projects that are being run to sort of determine how easily can we sort of, how cheaply can we actually generate these recycled panels. Unfortunately, the pandemic struck, and I'm currently not aware of the status of these projects, but I do know for a fact that they exist. You will also be pleased to know that as per the latest update from Solar PV Magazine yesterday, different teams in Australia, China are innovating, and a team in Australia. And also my conclusion, and I'll be happy to take any questions. My final comment would be that we need to design our products better across industries: cell phones, solar, power plants, ships, and any industry that any product you can think of. We need to stop thinking it out as merely waste management and actually start thinking of it in same line as Zoe mentioned, as resource recovery. We've put in a certain amount of energy and materials into manufacturing these products. We should now be designing them from an end-to-end perspective so that they can also be recycled, repaired better, recycled better, and be put back into the market or simply last much longer. We had similar products till a few years ago, and we need to sort of now shift out of this habit of use and throw and start thinking about resource recovery better. And you cannot, this is my manifesto, this is what I wanted to talk to all of our colleagues here, that if we sort of think of the world economy as a world economic engine, using fuel of our labor and our material resource in the engine of manufacturing, we cannot solve this approach by putting in more fuel and putting more manufacturing into this world economic engine. We need to start thinking from an end-to-end perspective. We need to start thinking of new paradigms, including decarbonization, including degrowth, including reducing our demand and our resources where applicable, where feasible, and start being more in tune with the flows of our planet. So that's my conclusion for you, and thank you for this opportunity.
Thank you so much for your presentation and for highlighting on this very important topic that we are facing nowadays. Now we continue with our session. Please stay with us if there is any questions or comments from the audience. Now we continue to our fifth presenter, and I'm very happy to welcome Sabrina Majabin from the USA. Sabrina will be sharing her presentation on the effect of food-in-column ratio on food waste and aerobic digester. Sabrina works as a project consultant at Civil and Environmental Consultants USA. Sabrina, please, the floor is yours. Yeah, we can see your screen.
Oh, thank you. Hello, everyone. This is Sabrina Mahjabin. I welcome you all to my presentation on effect of food-in-column ratio on food waste and aerobic digester. as we all know that food waste is the edible part of the produced consumables. According to FAO 2011, food waste is the highest amount of waste that has been generated, 30% globally, which is 1/3 of the food produced in this world. It is the largest amount in the municipal solid waste in developing countries and second largest in the developed countries. So to come up with an idea to lower the number in this food waste, anaerobic digestion can be a good option that I proposed in one of my works for my graduate studies. That is as we all know that anaerobic digestion is a molecular breakdown using microorganisms in absence of oxygen for the organic components, and we can get both biogas and digestase, which is a solid part out of that anaerobic digestion process. It can be doable for monodigestion of any anaerobic digestion can be impaired the biogas production. So to accelerate that, different researchers use different type of methods and they have success in their different results. So in the developing countries, still 90% of the rural peoples are using inefficient ways to burning their, to get the heat and energy for them. And they are doing it in indoor pollution that is causing serious indoor pollutions to them. And women carrying their children on their back while cooking in this type of situations expose them to different type of respiratory illnesses. So this is a serious issues in developing countries. So food waste, which is the kind of could be a one kind of solution to come up with this thing, and we can use the biogas that is being produced from this food waste anaerobic digestion in developing countries to help them with these issues. So my focus was to come up with a situation for developing countries. So the composition that you are seeing in this one, I used Food and Agriculture Organization's data from 2011 for developing countries, and that was that the food waste from fruit and vegetables is 60%, meat, fish, and dairy of 10% in their food waste, and food produce from grain 30% on their food waste composition. So for that, what we have come up with that, we are going to collect the samples for food waste. And as food waste is very acidic in nature, so we have to use some inoculum that in our case, we use the sludge and cow manure. And for that, we used for 6 months of operation of that food waste anaerobic digester. And the performance monitoring was based on leachate and gas. For the leachate, we took the data for the pH, chemical oxygen demand, and volatile fatty acid, and for it was composition and the volume. As per Chen in 2013 and year 2014, solid waste in the anaerobic digestion should be between 10% and 20%. And food inoculum ratio should not exceed 4 as per Hashimoto in 1989. So based on that and considering the economical conditions and sustainable conditions, we come up with 4 sets of reactors. Out of them, the first set of anaerobic digester was for the combination from Zaman's 2016 biocell studies. We used 2-gallon size of buckets that are being filled with 4 pounds of food waste with the composition that I mentioned, and it was inoculated with the sludge and cow manure with it, and it was airtight, and it was monitored for 6 months, and it was kept in the thermophilic condition to expedite the anaerobic digestion process. So as our concern is mainly getting the energy out of it, that is that we are focusing on biogas. So percentage of methane, what is shown over on these particular slides for the whole 6 months. As we can see that around after 40 days of after around 80 days of operation, 40% of methane was found in 87 and 88, which has the food inoculum ratio of 2. After certain points, which is around after 100 days, like all of the anaerobic digester sets get more than 50% of methane, except the controlled one that has high food inoculum ratio. And in the second graph, as you can see, that is the percentage of anaerobic activities, which signifies the changes in volume of methane and carbon dioxide. It's showing that after 40 to 60 days, every food inoculum ratio that we used across that 100% of it, which signifies that there is decrease in the carbon dioxide percentage and increase in methane percentage. But the controlled one, it could not get up to 100% due to its longer lag phase in it. For the whole 180 period, we monitored the cumulative biogas production for these, and the food inoculum ratio of 2 get it the highest amount of number, that was more than 200 liter per pound volatile solid of cumulative biogas that we were getting, whereas the other ones were less than 75. When it comes for the methane yield, when the methanogenic phase, like any anaerobic digestion system enters the methanogenic phase, it has the maximum amount of methane yield, which we can see for that particular 87 and 8, we got more than 1700 milliliter per pound volatile solid per day for that particular sets of anaerobic digesters, whereas for the other ratios, it was quite a less. For instance, for food inoculum ratio 3, it was less than 500, where it was more than 1700 for the food inoculum ratio 2. When we started to monitor, we were monitoring the leachate characteristics as well for the whole 180-day periods of our operation. So initially it was really low in number, means less than pH 5, which is acidic in nature, and which is quite relatable because food waste is really acidic in nature. So it was being monitored for the whole period of time, and we were using potassium hydroxide to maintain the leachate pH whenever we are measuring it. And after certain days, it started to show that all the anaerobic digesters were above 7, pH 7, which is needed for the methanogenic phase for the anaerobic digestion process. When it comes for the COD, that is chemical oxygen demand, it does mean that the degradation of the food waste or any type of organic materials like that we are doing with the anaerobic digestion process. So initially for all of them, it was really high. For control one, it was more than 100,000 milligram per liter, which ended up being around 70,000 in average. For the food inoculum ratio 2, it was less than 30,000 at the starting, and it went up to a certain time of amount, and then it went down less than 10,000. So whenever it was entering that methanogenic phase, which is around 3 months, after that, it started to degrade faster, and which signifies that it has faster degradation in the anaerobic digestion process. For the volatile fatty acid, it follows the similar nature as chemical oxygen demand and pH curve. And volatile fatty acid, how it works, it initially accelerates with time, and whenever we are in the methanogenic phase, that volatile fatty acid is turning to methane. That we can see it was happening after 3 months for each of them, because when it went to the methanogenic phase, it started to consume that volatile fatty acid and turning it to methane production, and which is making the volatile fatty acid in less amount in our graphs. So considering all of our conditions, when we are performing the gas and the leachate characteristics, out of all of our 4 sets of anaerobic digester, the lowest number of food inoculum ratio that we used was the best one that was giving us the best results. Thank you all, and I would like to answer any questions that you have. Thank you.
Thank you so much, Sabrina, for your informative and great presentation. I'm impressed so far with the high level of contribution of all presenters. It's going to make this evaluation very hard on us. So now let's move to and welcome our sixth presenter, Anissa Gumel. Joining us from England, Anissa will be sharing her valuable insights on the topic of analysis of municipal solid waste management in Nigeria. Anissa is from the University of Salford, Manchester. And Anissa, the floor is yours.
Thank you very
Share
much.
your screen with us.
Thank you very much, Dr. Mal. I would like to share my screen. Okay.
We can see it. Thank you.
Okay. Thank you everyone for having me. I am Anissa Gumel, and a final year PhD student from the University of Salford, and this is my research thesis. Now, before we begin, I would like to show you a picture here. This is a picture that was taken from a municipality in Nigeria. Now, I can sit down and tell you all of the health and environmental impacts that can come out of this, but that is not why we're here. However, I just wanted to call your attention for you to know that there are other developing countries that are still in their primitive stages of waste management. And this is something like it. Now, this is a conceptual framework that was developed in 2009 by the Integrated Sustainable Solid Waste Management in Asia. It is a perfect depiction of the life cycle of waste globally. So from the inside is a generation, from waste generation to collection to final disposal, including all the circular economy elements, which is recycling, and then treatment. However, that is not what I am discussing today. What I would like to talk about is the orange area and the green area on top, which includes the environmental, sociocultural, financial, technological, and institutional factors, which are supposed to be put in place for a proper waste management system to be effective, including the stakeholders involved. Now, the study is it's trying to discuss how developing countries, like I said earlier, are primitive in their waste management systems. And this study chose Nigeria as the geographical area, the case study for this research, because of its unique attributes due to its high population, due to its level of urbanization, and also consumption behavior as it is an emerging economy, which also combines with its limited resources, which means that the waste management in Nigeria is very poor, which has led to several health and environmental impacts. Now, the aim for this study is to analyze the current state of municipal solid waste management, basically, with these objectives such as the challenges affecting municipal solid waste, the opportunities that can be utilized, the criticality of these challenges, and the public's perception. However, in this presentation today, I am only discussing the challenges that were identified in my study. Now, I conducted a literature search, and with this literature, I discovered some gaps, which is the scarcity of updated research in this topic. Also, that the literature studies have not discussed the in-depth analysis of the challenges affecting municipal solid waste management. Basically, what has been done is just that they have been listed and certain recommendations has been given. So what my study does is bridging the gap to explaining and putting this word out that this happens for certain reasons, and this is how these challenges have occurred. Now, my methodology is a mixed method approach, but as I discussed, my challenges were acquired based on qualitative data for an interpretative approach, and that is what I will be discussing. After thematic analysis, some of the emerging findings included inadequate funding, lack of public payments, lack of enforcement, and so on and so forth, which have been classified thoroughly based on the initial illustration that I showed you about the financial, socioeconomic, institutional, and technical challenges. So some of the surprising things that have emerged from this study was that, like I mentioned earlier, the details of most studies discuss the challenges affecting municipal solid waste management, but did not go into details to explain all the nuances of these challenges. So for instance, now one of the most mentioned challenges was a lack of awareness that the Nigerian public has lack of awareness. Bear in mind that I conducted 15 interviews with 15 experts from various aspects of waste management in Nigeria, from academics to civil servants to activists, and so on and so forth. So these were the outcomes from these studies, that in between lack of awareness and the issue of funding, there's the issue of sensitization. Awareness cannot be created without sensitization. And over the years, no literature has mentioned sensitization as part of the challenges affecting municipal solid waste management. So this has shown also that there's an interrelationship between all of these challenges that affect municipal solid waste management globally. If there's a lack of awareness, it is due to in lack of sensitization. And in-depth analysis shows that the sensitization is not that there's a lack of it, but it is an ineffective one. Also, in order for sensitization to be materialized, there has to be funding. So which is what makes the relationship very apparent and obvious, that you need funding to conduct sensitization in order to create awareness. Also, with regards to funding, most of the studies discussed a poor funding and inadequate funding, but there were also issues that were discussed by the experts saying that the funding was mostly insufficient, and also there was a delay. So sometimes it wasn't the case that the funding was poor, but that sometimes it was being delayed due to certain factors. Another interesting finding was that there was an absence of policy, no specific policies for municipal solid waste management in Nigeria. Now, Nigeria got their freedom in the year 1960, which is over 50 years now, but there were no specific solid waste management policies, which explains why no policy implementation was effective, and explains the poor state of municipal solid waste management now. Up until the year early 2021, there were no specific solid waste management policies. The National Solid Waste Policy and Plastic Waste Policy were just launched early in the year 2021, which means earlier than only policies from public health and the oil and gas sector was borrowed and implemented for solid waste management. That explains the current situation now. Also, these were some of the emerging findings. Like I said, I also collected data to understand some of the opportunities that can be used for potential mitigation strategies, which included the introduction of circular economy, like Zoe explained earlier. Also, in partnership building, revenue generation, basically, which are all going to be combined to inform the framework that was developed in this study. So based on the criticality of the challenges, like I mentioned in my earlier objectives, it was discovered that there's an interrelationship among all of these challenges that affect municipal solid waste. And this outcome was based on the level of frequency of mention by all of the experts during the interviews. So the questions began with the current state of municipal solid waste, not just jumped into the challenges, the current status of municipal solid waste and what they thought about it based on their perception and experience, which showed that the issue of funding was mentioned over 61 times by all of the 15 experts that were mentioned. So this is how the hierarchy was created. After that, there was ineffective sensitization, then lack of awareness, and so on and so forth. So basically what this means is that if you can curb the issue of inadequate funding, it means that if funding is now available, it means that there can be effective sensitization, because what the experts are saying is that sensitization is ineffective because the government was not using various channels to communicate to people, to make them aware of the impact and the importance of managing their waste properly. So Nigeria is a country of over 250 ethnic groups, speaking over 500 different languages. If, for instance, communication is made only in English, or in the three basic languages, which is Hausa, Yoruba, and Igbo, that will never be sufficient. What about the other 496 languages that maybe probably do not understand, as Nigeria has a low illiteracy rate? So this is what this hierarchy does. In order to somehow, it means some of these problems can be prevented. So if there's sensitization, it means lack of awareness can be prevented. Also, when there's awareness, it means that negative attitude of people towards waste will also reduce. Based on these outcomes, the conceptual framework was developed. What is unique about this conceptual framework is that it lists the challenges based on the criticality, as I have just mentioned, and then the empirical nature of the opportunities that can be used as mitigation strategies, as well as the actors that are responsible at each stage of the mitigation level. So this is unique in itself, but at its primitive first stage, what is recommended to be done for further research now is basically conducting coming up with a systematic system, for instance, using interpretive structural modeling in order to understand systematically the hierarchy, because what I did was based on the frequency of mention from the experts. So what will be done next is to understand the hierarchy systematically of the challenges affecting municipal solid waste management. Why this is very important, because like I mentioned earlier, Nigeria has and other similar developing countries have a poor economic climate. They have limited availability of resources. So this will guide stakeholders and policymakers in order to understand and begin from a certain point, which by doing that can help in the prevention of other potential challenges. Thank you very much for listening. I am here for any questions you may have. Also, some of the my recommendations are basically part of the opportunities that I discussed: circular economy, proper communication, and introduction of waste education to the Nigerian curriculum. Thank you very much. I am here for any questions that you may have. Thank you for listening.
Thank you, Anissa, for your informative and excellent presentation, for highlighting the challenges of waste management in the Global South.
Thank you very much.
As a reminder, I also ask the audience to submit their questions and their comments in the chat box. Now, ladies and gentlemen, we have arrived at the 7th presentation of this session. It is with great pleasure that we welcome Saliha Mahmood joining us from the UK. Saliha will be presenting on the topic of behavior change and intervention for decentralized food waste management with black soldier butterfly technology. Saliha is from the Department of Chemical and Biological Engineering, the University of Sheffield, England. Saliha, the floor is yours.
Thank you very much, Dr. Ramani. Let's talk about behavior change intervention for decentralized food waste management with Black Soldier Fly BSF technology. Do we feel responsible for the waste we produce? A simple question that we need to think about. Like other developing countries, food waste management is not a new challenge for Pakistan, where more than 50% of the municipal solid waste is organic, with household food waste as a major contributor. It is a deplorable fact that the country with 40% population is food insecure. Around 20 million tons food waste goes to dumps annually, resulting in serious environmental and human health losses, and huge waste management costs are involved in it. Waste is valuable and it loses economic potential if it gets mixed. Its management is all about people, and people are not habitual of waste segregation at or near the source, which is the heart of any sustainable solid waste management system and circular economy. And then managing it right there is a decentralized approach. So food waste is yet an underutilized resource because of people's perception. They consider it as having a lower economic value, and it is not considered worth of recycling. Then I'm sorry, my presentation was stuck.
Yeah, now we can see it. Maybe you can continue in this way.
Can you see it?
Yeah, we can see it now.
Okay. Okay. So our linear economic development and aggressive consumption patterns have changed values and behavior that has deprioritized the concept of land waste management in the country. We are now in the 21st century, and I think that we should have realized that alone awareness about the negative effects of poor waste management does not work any longer. So the solution is to implement innovative behavior change interventions for encouraging waste segregation at source based on the psychological research, and that must have an attractive economic incentive. In this regard, the application of BSF technology, which is fast emerging, also declared as ecological engineers and crown jewel of the insects, is very promising in the treatment and valorization of varying types of organic waste, and food waste is their favorite dish. The technology is becoming popular because of the non-vector and non-pest nature of the insect, along with high waste reductions, waste sanitization, quick biomass productions into valuable products such as protein and fat-rich animal feed, stable soil conditioner that has a market, and reduced global warming potential with a forecasted market of $4 billion in the next 10 years. The study conducted in Pakistan was the first in which people were directly involved in BSFL operations, and the concept of BSFL assisted waste bins, the bins having the larvae to treat organic waste, was assessed as a substitute to the concept of conventional waste bins in terms of perceived practicability, their social acceptance, waste treatment, and bioconversion process. So in the first phase, awareness sessions were held with the 20 households about the benefits of BSF technology and a small-scale business model, which was followed by bin trial with the agreed households. Household feedback and encountered operational problems were documented to develop a user set of instructions that can be used in the second phase, and the reasons for agreement and disagreement were recorded for further improvement. In the second phase, the improved bins were provided to the households along with the bin handling tools to assess the waste treatment and bioconversion performance. And after 15 days, they were transported back to the centralized facility. Results showed that 50% of the households agreed to place and handle bins in their houses, and the main reasons for agreement include viewing this technology as a business opportunity and especially directly selling the larvae to poultry farmers in Pakistan, and considering it as a sustainable solution for the food waste management problem. Love for pets and availability of enough space were other reasons. The reasons for disagreement mainly include unwillingness of the households to spare time for this extra work and lack of open spaces, not habitual of waste segregation at source, and some feel uncomfortable for handling the bins in their houses, fear of insects, and not considering solid waste management as their own duty, but the duty of the government. It was also found that the bin treatment resulted in more than 80% waste reduction by weight and volume, and around 13% of the waste was converted into larval biomass, means protein, and 10% was converted as a soil conditioner, which was a stable soil conditioner and can be used as amendment for soil and plant growth. and major proportion was metabolized into energy and larval activity. It was found that waste moisture content significantly affected waste dry matter reductions, and that was almost 70%. Based on the results, I would like to say that, yes, BSF technology has a huge potential for social acceptance, and extended operational assistance along with the prolonged training sessions can bring in further improvement. It was people's positive attitude that led the successful implementation of the technology at source, at household level, with significant waste reductions and bioconvergence. And the feedback recorded by the household set of instructions and all the points of agreement and disagreement could act as a starting point for replicating the technology and could bridge a gap between industry, government, and academia for future interventions. It was also found that application of this technology at household level can bring in 70% waste management cost saving. So it's definitely a promising incentive to source segregation, increasing recovery and economic value of the waste components, and a milestone towards achieving zero waste goal by putting back an important resource in the food chain. At the end, I would like to conclude with the Gunter Pauly's, father of blue economy's remarks. When we are inspired from nature, we can find unbelievable solutions that we could never have imagined before for the sustainability of the Mother Earth. And sustainability is to bring into use what we have and generate value out of it. So we have BSF technology and abundant amount of waste. Decentralized waste management is the future that can make circularity a reality. How? Through economically attractive and viable behavior change interventions, and application of BSF at source can definitely encourage people to rethink food waste as a resource. Thank you very much. And I am here for any questions you have.
Thank you so much, Saliha, for your informative presentation and highlighting very important issues towards sustainable waste management. Now we have arrived at the 8th presentation of this session. Please join me in welcoming Shiza Aslam, joining us from Pakistan. Shiza will be presenting on the topic of mapping landscape of waste pickers in Pakistan, challenges, opportunities, and organizational strategies. Shiza is from the Circular Plastic Institute, Karachi School of Business and Leadership. Shiza, please, the floor is yours.
Thank you, Mani, and everyone for presenting here and being in the audience. Today, I'll be sharing some of the results and the observation that we have conducted through a project at Circular Plastic Institute. The idea for this project and the things that I would be sharing that would come as a learning point from my presentation would be around the landscape of waste pickers, that why and how they structure as a working group, how they see themselves as an entrepreneurs, are there economic sense within the waste pickers? And more importantly, can we see waste pickers as a single unit, as a single body, or there needs to be a bifurcation to allow the just transition and all of the recent amendments that we have seen, and also the kind of dilemma that we have been seeing in the union landscape, but also how to deal with socially sustainable plastic pollution or waste management aspects. So these would be some of the few points that I'll be discussing through my presentation today. Going forward, we had this particular project to assess the landscape within Pakistan, though it would be resembled to other developing countries. To approach this unique concept, we allowed ourselves to get into the stratified sampling. The idea was to, again, to look into whether we can approach waste pickers as a single unit, or are there actually different groups or stratas within the waste pickers themselves. So we took on 3 different cities in Pakistan, namely Karachi, Lahore, and Muride. All of them are mega cities with a population of 10 to 20 million each. We conducted 40 interviews with waste pickers in each of the city, and also additionally 40 surveys. The purpose of the interviews was to get more insight about their organization, their work structure, and how they utilize the social network and the benefits within. And the purpose of the surveys was to then assess what are the unique opportunities and challenges have been arising, and are those vulnerabilities, opportunities, and challenges could be unique to each group of waste pickers, or they could be said that waste pickers could be generalized and those particular challenges could be normalized as well. Within the waste pickers, then we stratified because of our certain experiences within Pakistan and from some of the literature, we thought to group them as segregated waste pickers. Within segregated waste pickers, we had itinerant buyers, sorters, partners who exchange waste components for good or money. Second, we had mixed stream waste pickers. Within them, we put together street waste pickers, transfer station waste pickers, and dump site waste pickers. Then we also had a unique waste group that we identified that was employed waste pickers. So those you would see perhaps with the municipalities or with the private waste management companies, or perhaps even with the NGOs. They comes in various forms and shapes, and they could be seen as sweepers, waste collectors, municipal workers. You could see them as truck drivers or somebody who is maybe helping with picking up the waste, and contracted sweepers as well. Then we had another waste picking category, which is not unique to Pakistan. It has been seen in some of the countries in India and in Dhaka others. But the kind of scope or the spectrum of them varies in each. So them we call them as self-organized waste pickers. These are the one who actually provide services at many places. So we call them as doorstep waste pickers or waste pickers as service providers. And then we have also daily wagers who come in and out, but they organize themselves. They look out for the opportunities for themselves. Here on the side, we also have a map of Pakistan and also pinpointing which cities we actually catered within this particular city region. Again, as I pointed out, can we consider waste pickers as a single unit, or there is a need to understand the waste picker so we can allow the just transition, so we can allow the unique challenges that each waste picking group would entail. In Pakistan, we have itinerant buyers. We also have employed waste pickers who may be driving the truck on behalf of the municipality or waste management companies, or we also see the sweepers. We also have self-organized service provider. In each of the city, municipality was not able to cater 100% of the waste collection. And that is not unique to Pakistan. That is common for many developing and low-income, middle-income countries. So in what we observed that in low and middle-income areas, waste pickers were actually serving as a small entrepreneurs, as a small startup companies, informally, of course, not registered. And they were providing those services of collection and transport to some of those areas that was needed, though we assigned them as waste pickers. And of course, then we also have daily wages within them. And the interesting part is, along the value chain of the waste pickers, you would find the unique proposition. So you would only find itinerant buyers, employed truck drivers, or self-organizers who provide services at the very beginning of the waste value chain where the waste is generated. So they have their close interaction with the source itself. So they could also have the possibility to get maybe perhaps a better value waste, a segregated waste, a less contaminated waste. As you move forward, you would see there are parks, there are communal bins, and there's a different set of groups. So earlier there was different, and now we have a different set of groups. You would see municipality sweepers there, not truck drivers so common, but sweepers as a different, and we call them as sanitary workers. We also have waste pickers, then street waste pickers, who are most common at the second stage of the value chain. And they come perhaps maybe visible at the parks or just retrieving and reclaiming waste from the communal bins. Moving forward, we have another stage typically in the waste value chain, which we call a transfer station. Here, commonly in Pakistan, we also have a local name. We call them as Kachra Kundi. And these could be official, this could be non-official as well. Some are more controlled and some are less controlled. So there are those managerial aspects to it. And there commonly we have a generalized or general transfer station, we call them. Moving forward, once it's scattered, the waste is then transported to landfill or the dump sites. And then again, there is a different strata or a different group of waste pickers. We call them as landfill waste pickers. In Pakistan, what we observe that waste picking is actually a male-dominated perception or a sphere. So most of the time, it is male-dominated and run by men mostly. Though women are there, but we see them mostly included in official or maybe more protected spheres, let's say more contractual protection is there when they are contracted with municipality or with maybe perhaps the private waste management company or an NGO. At points, although it might be male dominated across the value chain, there would be instances where we have seen that there could be points where women introduction could be in place. For instance, at the very beginning, when we see waste as a self-organizers or waste pickers as service providers, they usually collect their waste and they might take it to home, where the woman in the household would allow or partake in the sorting and segregation of the waste. So at that point, yes, we saw some of them. We also observed that in cases when the male waste pickers might be sick or there are some certain challenges that he cannot go for waste picking since they did run on day-to-day basis, on those particular days, they would maybe ask for request a younger child in their family to maybe help with the waste management system. That perhaps has an inclusion of child waste picking, but then has to also to kind of understand the cultural norms around it. For instance, among these groups, we have Muslim majority waste picking groups in the initial 3 phases at least. We saw that at the point of source. We also see them as communal bins, also at transfer stations. So in those communities, the woman dominancy of partaking was relatively low. At landfill waste picking, we saw that there was other minority groups as well, particularly non-Muslims, and they had more gender inclusion because of the cultural norms and the religious practices they were practicing. Nonetheless, when we were defining who to include as waste pickers, we were come with a challenge that how to set the premises around waste pickers. So internationally, there is no consensus or no standard definition around waste pickers. So we had this challenge whether we want to identify or include or set our premises around waste pickers as one who would only primarily relying on a waste picking income source. So their whole or primary stream of income is waste picking, or can we also include those who may be doing waste picking once they need additional money, or maybe when they found or come across something of a relative market value, or those who maybe come here now and then according to the seasonality or the needs according to the downturn. So we were presented with this challenge is what we observed in case of Pakistan. It is actually very hard to assess this economic stratification, that the onus that or the ratio that how much of each waste picking group is actually reclaiming or relying on a waste picking. In case of waste pickers for a service provider, it was unknown because they also charge for their services, although they are not allowed officially. But since that's the case, they charge somewhere between 200 to 300 rupees, which is around or less than $1. From each household in low and middle income countries. And in cases, they were very flexible, which was a very interesting point, that in case the household, if they provide them with segregated waste, they would lower their fee charges to as low as maybe 50 rupees per day. So that also kind of indicated that they do rely on a waste material. They do kind of appreciate the value of segregated waste. So just seeing them as a service provider and not addressing them as a waste picking, that did not really cater about that. That put us a question, no, we do want to include those who perhaps may be coming in and out and not necessarily relying solely on waste picking, but other aspects as well. Moving forward, we kind of observed that under all of these aspects, we have some are there who come in this waste picking sphere as an individual, or when there is an economic downturn or a challenge, and for some it's a family business. And when it's a family business, they already have certain experiences with them. They have already certain notion and entrepreneurial and economic sense to it, which allow them to not be too exploited at every stage. So in terms of mixed waste stream, we found that the street waste pickers are actually the ones that are more exploited, because they often come as an individual. They have very low sense of even what items to pick and which one has the most value, and they would come across. The ones who are with family businesses, they would already have that sense, or even at the internal transfer station, because there are many waste pickers already working in close proximity or premises. So there is a lot of peer exchange or learning, cross-learning from each other. So that's allowed them to be there. So that has been one of the consensus in everywhere. One interesting part we observed in case of Pakistan, that in the literature, the junk dealer, here named as Kabariwala, they are seen as an exploitive entity, a patronage system that kind of like keep a greater share than waste pickers, although waste pickers do the max of the work, they are backbone of the value chain. But that wasn't the only part of the story. We found that the Kabariwala actually play a very important role in the organization and the structuring of waste pickers. So in cases, since Pakistan does not have any social protection net, by social protection net means if there is a funeral, if there is a death, if there is a marriage happened, or waste pickers in general being poor, they need certain
few minutes remaining for the end of the presentation, please.
Thank you. So in that case, Kabariwala would come in and would have them sort and organize. So that's why the organization of the waste pickers, we saw that was almost within the range of 2 kilometers to 15 kilometers in a very close net process. Again, as we have seen that there are several groups of waste pickers, they are also see them as competitors among themselves, and in some cases the alliances, although the alliances part was very low, and most of them see as a kind of competitor with each other. For instance, the waste pickers as service provider, they were not in so good terms or contracts with street waste pickers and waste pickers as service providers. Again, transfer station waste pickers, they would not allow street waste pickers and others to come in their provinces. So we saw with the landfill system, so they were protecting each of them. Some of the challenges we came across that we saw that waste pickers were observing was urbanization and population growth. Because of the high-rise buildings, they were being seen as honest, and also that need them more maybe physically fit to provide their services and allow them to be good. There's a commercialization aspect of cities, so they were not allowed to enter in some of the commercial spaces because the restaurants and the other entities, they have this honest that they're ugly, there is nuances, and they would not be so customer friendly. Seasonality has an impact. In summers, they get more waste, but low prices of waste. In winter, there are higher market value of certain, let's say, PET bottle, but a lower waste. So when developing an intervention about waste management or waste pickers, it's important to look how you provide the package or how you include those seasonality aspects, because that affect their revenue. Contracting and outsourcing in Pakistan, the waste management is quite politicized. So it really depends upon your connection and network if you can get a contract for waste picking as service provision. And again, we saw their waste management practices, even the provision of door-to-waste waste collection provision that affects waste management or the waste pickers themselves, especially the street waste pickers.
Sorry, Sheila, to interrupt you again, because we are really behind time.
Yeah, I'm almost done. So.
Remarks. Thank you so much.
Thank you. So with that, yeah, I'll just conclude and stop sharing my screen here. Thank you, Amani.
Thank you so much, Shiza, for presenting the results from your project. It's very interesting, and it's very important, like, to highlight on the role of waste pickers, which is very rare and always neglected in, unfortunately, in this sector. Now we move to reach the final presentation of this session. It is with great pleasure that we welcome our last presenter, Tolulope Omeyeni. Sorry if I'm pronouncing the name wrongly. She's joining us from Nigeria and will be sharing her topic on the assessment of interventions to support waste management circularity transition, a case study of Lagos. Our presenter is from Circular Economy Innovation Partnership, and please, the floor is yours. Please, if we can stick to 8-minute presentation. Thank you so much. We can see the screen as well.
All right. Thank you so much, Dr. Amani Malouf, for the introduction. I must confess that I have learned a couple of things from all these speakers that have presented so far. Well done on the great job you're doing. Straight into the presentation. Now, the research, which we call SNAP survey, is an assessment of different waste management interventions implemented by initiators in local communities to support waste management circularity transition. Now, for the purpose of this research, initiators can either be corporate organizations, NGOs, or the government. Okay, so there are five parts actually, but four basic parts of the research. The first is database building. Now, one of the problems identified before the implementation of this research is that there is no data that captures information about interventions, types of interventions, categories of organizations that engage local communities and their locations. Now, this is because many of these initiators carry out their project interventions in silos and most times without effective publicity. Now, this research was designed in such a way that survey questions captures all of this information. The second part of the research is the position paper. Now, the position paper, otherwise called the short case report, outlines the key themes that were identified in the survey. And of course, it also talked about all of the findings as it relates to the themes that were identified in the survey. The third part is a long case report, and this describes 3 different community engagements and evaluates responses from the project community. Now, the long case report triangulates findings from the database building, which is from the survey, and the position paper to develop a how-to guide, which is the last part of the research. The how-to guide is a practical document that supports project initiators to plan, identify partners and resources to implement their interventions, and also to help them set realistic targets actually for their interventions, and most importantly, to encourage them to share findings about their project interventions, yes, so that there is a database building put in process. Okay, so prior to these steps, a database of organizations that have responsible waste management mandates was set up from membership of industry association. For example, LAGRA. LAGRA is Lagos Recycling Association, and of course from online searches. So we contacted 86 organizations. However, 52 organizations completed the survey. For the survey, mixed method was used in developing the survey so that we could get quality responses. And the structure of the survey is such that it captures key themes, including types of interventions, nature of interventions, interventions focus, intervention audience, and the challenges faced by initiators. The other step is the preliminary analysis, preliminary analysis. Now, from the data collected from the completed survey, the responses collected was analyzed using descriptive and inferential statistical tools to explore all of the themes that was identified. The next step is the long case. Fast, I want to keep to time. So the next step is long case survey. And this long case survey, like I said earlier, it describes and evaluates 3 different community engagements. Here we interviewed the initiators to have a full grasp of their intentions when designing, planning, and implementing their interventions. We also reached out to community stakeholders that benefited from these interventions so that we could compare and evaluate the impact of the project as compared to the intentions of the initiator. The last step is analysis. So for the analysis of the long case survey, we used saturation approach, we used evaluation metrics and observations to analyze all of the findings from the long case survey. Okay, observations. The research actually we were able to observe about 8 findings, but for the purpose of this presentation, I'm going to be sharing 3 key interesting observations. From this pie chart, we can see that we have the larger portion of the pie chart to be 65% for corporates. Now, this means that corporate entities identify themselves as initiators. Now, this result implies that business organizations are active and the drive towards repositioning waste management in local communities. However, a further evaluation of this corporate respondents shows that almost all the companies are directly involved in the waste management value chain. The next observation from the graph, we can see that the note here is interventions may not necessarily be human-centered. And when I think the 6th presenter was presenting, I felt this research is complementing our own presentation. Now, we see from this graph that the keys here, we have the green to be corporate, blue to be NGO, and the yellow to be government. Now, we saw that a good number across the initiators chose cleanups, incentive scheme, and community sensitization as their nature of intervention. Now, looking deep into this evaluation, we saw that not necessarily is it that these interventions are human-centered, because at the long run of evaluation, the environment in general is the target focus for all of these interventions that was carried out. And this suggests that the physical environment and probably volumes of recyclables collected from this community, rather than member community, are focal points of interventions. The last observation here is that there is inadequate funding structures. Again, this agrees with Kabir's presentation. We can see again from the graph that these initiators, ranging from corporate, NGOs, and government, self-fund their interventions. And we see that even some of these interventions are funded by family and friends donations. So that shows the extent to which there is inadequate funding put in place to carry out waste management interventions in local communities. Final notes, I'll say that sustainable and human-centered community interventions require substantial funding. So if we want to carry out sustainable and human-centered interventions, we need a lot of funding. And this cannot be assumed to be commercially viable. That means these interventions cannot be assumed to be commercially viable investments, even if there are commercial motivations for engaging with communities. A good recommendation here will be that blended finance and other pool of resources should be made available for initiators that carry out waste management interventions in local communities. Thank you for listening. I'll be available for questions. Thank you.
Thank you so much, Tolu, for your great presentation. It agrees a lot with what was presented earlier from Anissa. I suggest that you sit together also during this conference and collaborate for better waste management in Nigeria. So now with that, we conclude this session. This is the first session and we had 8 speakers. And thank you all for the speakers for participating in the conference. The presentation in session 1 have been excellent, making it challenging for us to select the best presenter. Thank you for your outstanding contribution and for the audience for engaging with us. Please, you can keep on sending your questions for the last presenters of this session. Now let's proceed with the second session of the conference. I leave the floor now to my colleague, Dr. Aziz Islam, co-chair of the Research and Innovation Working Group, who is going to moderate this session. Welcome, Aziz, the floor is yours.
Hello everyone. Thank you so much, Awani, for the nice introduction. My name is Aziz. I'm the co-chair of the Research and Innovation Working Group and working as an assistant professor of instruction at the University of Texas at Arlington. So I'm going to moderate this session. So welcome everyone. We are about to start the second session of the abstract competition. So we are very lucky to be joined by 9 speakers. Please remember to submit your questions through the chat and include your name. The speakers will answer you through the chat panel. We ask all speakers to closely pay attention to the chat box and please answer the questions. I would like to welcome our first presenter, Marcelino N. Luna Jr. from Philippines, whose presentation title is Community-Based Design Compost Processor, its Economic and Environmental Impact Assessment. So Marcelino is from St. Louis University, Philippines. Marcelino, you have the spotlight.
Thank you, Dr. Islam. Greetings from the Philippines. I'd like to share my screen. I hope I'm audible and you can see my screen.
Yes.
Okay, so imagine if biodegradable waste will be managed at the source, which means that there will be no collection and there will be no transportation of this type of waste to the landfill. So it will be very beneficial if this will be managed at the household level. This will be beneficial in terms of economics and environmental as well. So today, I'm going to talk about the community-based design compost processor, focusing on the economic viability and environmental impact assessment. I am from School of Engineering of St. Louis University, Philippines. You know that biodegradable waste is the largest in terms of our municipal solid waste. And this becomes a problem if these types of waste will be mixed with other types of waste. And so it will cause environmental degradation due to its toxic byproduct, which can cause, because of its leachate, it can cause pollution to our groundwater. And if it's directly applied to the land, it will degrade the land quality. And so to overcome this problem, I will present to you this device, community-based design compost processor, that will manage the biowaste at the household level or at the source, that will produce and convert the biodegradable waste into a valuable organic byproduct. Now, the focus of these types of this study is on its economic viability and environmental impact assessment. So the calculation of economic and environmental impact assessment will be very important, especially if it will be determined as a worthwhile strategic solution for this type of waste. What makes this device interesting or system interesting, it is that its community-based approach. According to World Bank 2019, community involvement is one of the keys for a successful waste management. And this type of system was based on the preferences of the community, of the stakeholders, of the household. Before that it will be fabricated, the preferences of the stakeholders were incorporated in its early design stages. Another what makes this interesting is that it's continuous mode of operation. Many of the composter is a batch mode operation, but this is a continuous mode, meaning that it is continued because of its continuous feeding due to its two-stage operation. And it can be scaled up because of its its operationability. It can be scaled up to different scenarios. Okay, to achieve the objective, scenario-based analysis was conducted in terms of its economic viability. So there are two scenarios that were done in this activity. We have the scenario A, or the barangay level scheme or the village level scheme, wherein the residential areas produce biowaste, and this composter will be able to manage and convert the biodegradable waste, and it will be as this waste will, or the compost byproduct will be centralized and will be processed. There will be sieving and screening and packaging, which means that on the barangay level, it will be marketed to private or public sector. So the other scenario, which is the household level scheme, will be on the household level operation. That after the biowaste were generated and converted into a valuable byproduct, the household is directly direct in the operation, especially in the marketing to public or private individuals. On the other hand, in terms of its environmental impact, we have computational analysis that were conducted using the Institute of Global Environmental Strategies, and the Intergovernmental Panel for Climate Change. GHG emission were calculated, especially the GHG avoidance in terms of transportation. and GHG emission in the landfill, GHG emission in composting and avoidance due to the potential replacement to the synthetic fertilizers. And so the key findings of this study in terms of economic viability is that there is a negative return of its investment, especially if it will be managed at the household level. And so what we did is that we have to come up with break-even or baseline cost for its profit, for its profitability. But what makes this interesting is on the environmental part of this study, because yes, this could result in a negative ROI, but in the long run, it has more beneficial in terms of the environment. And there is also, if it will be marketed to private, it will be an additional income generating activity for the household. And cost saved from transporting bywaste to the landfill is also enormous. It's around, if it will be converted into dollars, $300,000 per year. Now, in terms of the environmental analysis, many greenhouse gas emission, there are 209.72 green gigagrams of methane could be avoided annually, averaging to 27% methane reduction in landfill. Also, there will be evaded GHG emission of 28.72 kilogram of carbon dioxide equivalent per ton of bywaste in terms of hauling and carrying of bywaste to the landfill disposal sites. In addition, 0.02 gigagrams per year of GHG emission could be saved due to the potential use of compost as soil conditioner amendments. So the overall greenhouse gas.
Sorry to interrupt you. You just have 1
Yeah.
minute left.
Okay. So the overall net GHG results led to negative values, which means substantial potential savings can be attributed. So key takeaways here is that every sector needs to recognize the important role of decentralized composting in sequestering carbon and improving degraded soil. This also will be beneficial to the achievement of climate neutrality by 2050 due to the negative net GHG emission. So this economic environmental study hopes to inform policymakers and stakeholders the local and global contribution of composting and its effectiveness in terms of strengthening, especially in strengthening this kind of endeavor towards the achievement of bioeconomy, circular economy, and green economy. Thank you very much for your kind attention. And we encourage everyone towards sustainable development goals. So you can contact me at this email. Thank you very much.
Thank you so much, Marcelino, for the excellent presentation. Now we will be hearing from Mohit Somani from Oslo, Norway, whose presentation title is Assessing the Performance of Biocover in Methane Emission Control at Old Landfills. Mohit is from Norwegian Geotechnical Institute. Mohit, the floor is yours.
Thank you. Can you see my screen?
Yes.
Yeah. So most of the speakers so far have talked about not sending biodegradable waste to the landfills. But in this presentation, I will give some solution to what if the biodegradable waste has already been sent to the landfills. So the title of my talk is Assessing the Performance of Biocover in Controlling Methane Emissions from Old Landfills. So as it is well known that landfills often produce landfill gas, which is mainly because of the degradation of biodegradable waste. And typically this landfill gas mainly consists of methane, which is around 50 to 60% in volume. And it is a general estimate that landfills are third largest source of anthropogenic generation of methane. So conventionally, all the landfills after the end of their active life should be capped with the soil cover in order to control methane emissions from them. But it has often been observed that even after covering these landfills, there is a fugitive emission of methane. So in this project, which was carried out as a part of my previous postdoctoral program, we have assessed the feasibility of landfill biocover to reduce methane emissions, to reduce fugitive methane emissions from landfills. So biocover is mainly a type of substrate which can degrade methane at the site itself. So in this project, we have used landfill fines as a substrate in order to reduce methane coming out of the landfills. You know, like methane can be degraded easily into CO2 by some aeration and by some kind of, methanogens. So in the literature, people have used several material as a methane degradation substrate in order to reduce methane from the landfill itself. But the beauty of our project was that we have used waste material itself to control methane emissions from the landfills. So the landfill fines, which are derived from the landfill mining process, were used as a methane degradation substrate layer or biocover layer in our approach. So the main objective of this research was first, to assess the laboratory feasibility of landfill fines as a biocover substrate by performing batch incubation testing. And second was to assess the long-term monitoring of the methane degradation layer in order to reduce methane emissions from an old landfill. So the site was located in an island at a place called Estonia. So the first approach was to extract out landfill fines by the process of landfill mining. So we have collected around 80,000 tons of landfill fines with the process which is shown over here. So this was the landfill site, and we have performed the process of landfill mining, and finally this fine fraction was collected and its suitability as a biocover material was assessed. So this material was characterized on several aspects which are listed in the regulatory protocol to make its feasibility assessment to act as a biocover layer. So several analysis was carried out by performing its heavy metal analysis, by analyzing its respiratory activities, LOI, pH, etc. And most of the analysis, when we compared with the limiting value, suggests that yes, this material has a potential to act as a landfill biocover. However, there is a significantly high concentration of zinc, as well as there is some problem with respiratory activity. So we have mixed this landfill fines with local soil as well as with sludge compost to improve its property. And finally, we arrived at the recipe that 60% of landfill fines plus 20% of soil plus 20% of sludge compost can act as a best substance to act as a landfill biocover substrate. So the next part was to install or to place this biocover on a landfill. So here is the schematic approach of our schematic representation of our approach. So landfill was leveled with the help of levelers, and on the top of the landfill a gas distribution layer of around 30 centimeter was placed, over which a methane degradation layer which was consist of landfill fines and other material was placed, which was about thickness 1.5 meter, and this was finally covered with a vegetative grass. And at several locations gas monitoring wells were installed in order to assess the long-term performance of methane degradation inside this biocover layer. So this is how it looks at the site. So you can see the waste was leveled, over which a gas distribution layer was placed, and which was finally overlain by a methane degradation layer. At several locations, these kind of gas monitoring wells, which is also shown over here, were placed in order to assess the long-term performance of methane degradation. So after the placement, the next task was to monitor the efficacy of this biocover. So at a regular interval, emissions from the top were measured you can see from the pictures that during snow or during summer and during rainy season, we have, collected observation or recording of methane emissions from the top of the biocover. And what we have observed that initially when there was no biocover at the site, the emission were 350 tons of methane per year, which reduced down effectively after the placement of this layer. So you can see that methane emissions were only concentrated at the center. That too, I mean, like the extent was not very wide. Similarly, at 50 centimeter down the biocover layer, there was, significant amount of methane, but so this was the surface emission measurement of methane coming out of coming on the top of the biocover layer after 2 years of its installation. Then a long-term monitoring with the help of gas monitoring wells, which I have already shown in the previous slides, was also carried out, and the results are projected over here. So you can see that there was a significant decrease in the concentration of methane. So here initially it was 60 to 70% of methane, which reduced down to less than 5% after the placement of this biocover layer. So it shows that yes, these landfill fines have a potential to degrade methane into CO2 and other substrate. And the depth-wise analysis of this methane degradation also shows that in the top 20 centimeter, the reduction was, or the degradation of methane was very high, whereas in the bottom it reduces down, which was obvious. And then in order, yes,
reminder, you have just 1 minute left.
Yeah, I'm winding up. So in order to prove our hypothesis, we have also carried out the microbiological assessment of this biocover substrate. And this microbiological analysis shows that there is a significant presence of methanotropes, which are the bacteria which can degrade methane easily. So yes, the presence of methanotropes help methane to degrade into CO2. And the conclusion derives are listed over here. In a nutshell, yes, there is a potential of waste material to degrade methane coming out of the landfill, and mainly because of the presence of microorganism. And thank you. So this is how the landfill looks after the placement of biocover on the top. Thank you so much.
Thank you, Mohit, for delivering such an educational and insightful presentation. So to everyone, please feel free to share your questions and comments in the chat box. We ask all speakers to kindly remain until the end of your session to address specific questions. Let's have an engaging and interactive conference. Next, we have the pleasure of introducing our third presenter, Tina Anthony from UK. Tina will be presenting the topic of post-consumer polyester waste recycling in Europe, challenges and opportunities of closed-loop practices. Tina is from London College of Fashion, University of the Arts, London. Tina, please share your thoughts on this interesting topic.
Hi, everyone. I assume that you could see my screen.
Yes.
All right. Okay, thank you. So hi, everyone. Good morning. And before I start my presentation, I would like to extend my gratitude to the organizers of this conference for this valuable opportunity to present my research. So I'm Tina Anthony. I'm a recent graduate of MA Fashion Design Management program from the London College of Fashion. I'm here to share my insights and discoveries on my research, post-consumer polyester textile waste recycling in Europe, the challenges and opportunities of closed-loop practices, which I've been passionately researching for the past few months. An increase in consumption has directly contributed to an increase in waste generated, accounting for just 1% of clothing being recycled into new clothes. And the lack of demand for recycled material and limitation in technology which enable recycling clothes into virgin fiber resulted in UK and European markets having a very low recycling rates. The amount of clothing produced and discarded is currently increasing faster than what our recycling facilities could handle. And this is indeed creating a negative environmental consequences. Here, the number speaks for itself, with more than 15 kilograms of textile waste per person produced annually within the Europe, the post-consumer clothes and home textile discarded by the consumer stands as the largest source of textile waste, which accounts for a staggering 85% of the total textile waste that is produced. Before we move into the objectives of this research, it's important to understand the prevalence of polyester. Globally, 109 million tons of fibers were produced in 2020, of which 52% were like polyester. Now, the materials are a central unlock for circularity, and their selection needs careful consideration alongside the technology and infrastructure available to handle them. Many brands have introduced circular initiatives to address this material in their clothing, but the overwhelming majority still rely on virgin fossil fuel-based materials such as polyester. As the demand for recycled fiber is increasing in popularity, more brands are increasing their recycled content. And in 2020, the market share of recycled polyester was 15%. But this increase in recycled fiber is mainly attributed to recycled PET bottles, or the plastic bottles, which is made up of majority of the recycled feedstock. And here the PET bottles, or the plastic bottles, fail to address the need for textile-to-textile recycling and doesn't really stimulate fiber-to-fiber recycling within the polyester textile landscape. Despite the limited global capacity to recycle the polyester clothing, the fashion industry is intending to double the use of polyester by the year 2030. Although the academic journals up to date investigates the strong claims and impacts of textile recycling, research regarding polyester textile waste recycling is very limited, and this has sparked my interest to further investigate the barriers, challenges, and opportunities for recycling post-consumer polyester textile waste within Europe and UK, and to probe the current closed-loop practices in textile recycling sector to determine potential opportunities and area for opportunities. And for this research, a comprehensive literature review was conducted to capture the main topic of global textile waste recycling and the polyester landscape. So this included most recent and credible academic journal, technical papers, and reports. The existing landscape of post-consumer textile waste, along with the critical analysis of key theories concerning textile waste and closed-loop practices within academia, was analyzed, considering how it can be utilized to achieve a closed-loop ecosystem within polyester to overcome the existing barriers and challenges. For this research, 11 industry professionals from various backgrounds within textile were interviewed. It was semi-structured interviews, and narrative inquiry method was utilized. After the interview, a thematic analysis of the interviews were conducted, and patterns were interpreted using the thematic analysis approach. So the key findings of this research, from the two research questions, which are segregated into challenges affecting the recyclability of post-consumer polyester textile waste recycling and the potential area for improvement within recycling to derive opportunities, the key findings were lack of financial investment for recycling technologies. So it was clear that we had a very, we were lacking within the investment sector. So we didn't have any investments to scale the recycling technologies or to progress within recycling. And there was this lack of product and design innovation. Effective design innovation is crucial, and product must be designed and developed after considering the end-of-life phase of the product with limited complex materials involved. Also, we had like significant barriers to sorting. So sorting and collection were like very limited. People end up putting their waste in textile waste, especially textile waste ends up in the household garbage bin. So this was also a major barrier that was affecting the recyclability of the polyester textile waste. The lack of directional policies to elevate textile circularity. So it was also clear that lack of policies such as EPR, which is implemented by France and recently by Netherlands. UK or many other European countries did not have any policies that would stimulate textile recycling for collection or for manufacturing or anything. So lack of policies were also a major barrier that was affecting the recyclability of polyester textile waste. The potential area for improvement were cost efficiency and commercial viability. So in order to scale the recycling technologies, we need technologies that are commercially viable, and essentially it's required like right quantity of feedstock. The feedstock is really expensive when it comes to virgin polyester. So right quality of feedstock and availability of feedstock at the right point of time is also very much essential. Fiber to fiber recycling. When it comes to fiber recycling, many brands need to manage their waste and utilize it as a resource to make profit out of it. So strict feedstock requirement for polyester is required when it comes to fiber to fiber polyester waste recycling, and it's essential to stimulate textile to textile recycling to derive more opportunities. Ensuring price parity of recycled polyester with that of the virgin polyester is also another potential area for improvement to derive more opportunities. So from the key findings that were derived, I came up with 3 recommendations. And the 3 recommendations were securing investment, design for circularity, and policy and EPR implementation. So it's important to secure investment from various stakeholders that is involved within the process. And design for circularity, it's essential to design products by considering all the aspects of people involved in it, from the manufacturing stage to the end of life phase. We need to consider the entire supply chain and the value chain involved in it. And implementation of policies and EPR. When discussing about UK, it's important to have EPR, especially for textiles, to have a very good recycling rate and to facilitate more recycling within this. So from the recommendation, I came up with 2 framework. So my proposed design approach for implementation of design for circularity is here. This was adapted from Goldsworthy's design for cyclability. Rather than considering recyclability from the point of disposal, implementing design for circularity requires considering the material composition starting from the design and product development stage. And the proposed design approach for implementing design for circularity will address the initial material selection at the product development stage and address the onward recyclability in the context of polyester textile waste. Despite the blends and dyes involved in polyester garment making recyclability a complex procedure, the material consideration in the design and development stage makes design for circularity a viable approach to facilitate closed loop practices. And when it comes to EPR, regulatory mechanisms such as extended producer responsibility schemes and targets for recycled content could support advancements in recycling technologies. Moreover, introducing such schemes can help shift the responsibility of textile waste collection from municipalities to the brands, preventing unsold inventories from being incinerated or discarded in the landfills.
Yeah, your time is almost over. So can you please go a little bit faster?
Yeah, I'm almost done. So this is last slide. So the limitation of this research is the limited sample size of the participants. As I mentioned, like we only had 11 participants for the study. So that is one of the major limitations. And this focus solely on the European region. So this is also limiting the opportunity for this data to be globally scaled. And the further research for this study would be like on advanced polyester and how we could segregate blends and dyes within the polyester. So that is the end of my presentation. I welcome any questions that you have. Thank you.
Thank you so much, Tina, for the excellent presentation. Please join me in welcoming our 4th presenter, Milan Totali from the UK. So Milan will be sharing his research on the topic improving quantification of MSW open burning using machine learning. a novel approach for data limited countries. Milan is from the Veolia, UK. Milan, please, the floor is yours.
Thank you, Dr. Azizul. Hi, everyone. Let us start by picturizing a very poor neighborhood that is densely populated but has no waste collection service. What do you think happens to all the waste that is generated? Well, it's mostly dumped somewhere or burned. For the residents, burning waste seems to be the most logical thing to do because it's an easy way of clearing the mess. And they have been doing it for a very long time. But little do they realize that this activity has a very serious harmful consequence. Good morning, everyone. My goal today is to share what I've learned about open burning, give an overview of a machine learning technique that I've developed to measure the extent of open burning, but most importantly, it's to raise awareness about this burning issue. Now, before we go into the machine learning part, let's try and understand what open burning of waste means. It is a very crude activity which involves burning waste at low temperature without much mixing and without proper air circulation, producing a large number of unpredictable products that are harmful for the health and the environment. A number of factors actually contribute towards this action, which involves lack of collection services, social norms, and even policies at a government level that recommend burning of waste to avoid a sore sight on the streets. Now, the bigger question, how much waste do we burn? Well, that's the tricky part. The best estimate is that 40% of the population burns waste, but we are not sure because of the lack of data and the resources towards the sector. So I decided to explore the methods that have been reported to understand how much waste is being burned or how many people burned waste. So I did a systematic search review of the literature to understand what methods were available, what were the limitations, if I could do something to improve the methods and fill the gap, for which I use machine learning. Of the studies that were selected, I noticed that the estimate of burning was either presented as a prevalence of practice, which is basically telling us how many people burn the waste within a population, or the amount of waste that is being burned, as in the quantity. The methods varied from saying taking assumptions by experts or doing surveys through questionnaires, doing field observations, doing distance sampling method. But what was striking was all these methods were trying to find a common element, which was trying to understand what fraction of the population is actually burning the waste. Now, this got me thinking, because many of these countries where open burning is prevalent, there is little resources towards spending for these research. So what if we could use the existing data and try and find what is the fraction of population that burns waste? This led me to think and model the whole behavior of open burning. Essentially, open burning is a behavioral decision that is made by the individuals based on the situation they are in and depending on a number of socio-economic factors. What if we could model this behavior based on the number of socio-economic factors? So I hypothesized that and selected a few factors that have been reported in the literature to be correlated to the activity of open burning. For instance, a household is more likely to burn if their waste is not collected, if they are located within a rural community, if the education level of the household is very low, and also they belong to a particular social strata which is not capable of paying for their space services. But this was tricky and it was not straightforward, because the relationship often is not straightforward as it seems to us. This is where I use the power of machine learning. The machine learning helps us to decipher complex and nonlinear relationships, and it has been reported to do this really well in the past in literature. So in a nutshell, without going in too deep of machine learning, what it basically does is we give a data set, a historical data set to the machine, and ask it itself to learn if there is any pattern between the factors and what happens if these factors do come in congruence and what happens to the action. So basically, we are asking it to learn from the data that we provide and decipher a pattern and then predict the future. So I fed the algorithm. I used 3 algorithms, and I fed the algorithm with almost 25,000 data points, of which randomly 80% of the data was used to train the model. And then the remaining 20% was used to predict and test how efficient the model is. As you can see on the right, the decision tree model gave a prediction at the accuracy of almost 90%, which showed very promising results. Now it was time to test the actual model on a different data set from a similar kind of rural environment. So instead of teaching the algorithm, I gave it a new set of data about the socioeconomic factors and asked basically to find me the result of how much fraction of population actually burns the waste. Now, as you can see on the right, the results were really promising, especially for the decision tree, which had a very high accuracy. The machine learning outcome was comparable to the actual surveys that were conducted for the same data set, for the same socioeconomic setting and the same study area using survey or census. Now, this is all exciting for me because this gives a new opportunity that has not been explored before to understand this very complex and often harmful activity that is hiding in plain sight. This is also exciting because if we have a bigger data set and if we can include a lot more algorithms, especially the latest deep learning techniques, to decipher the relationship between these factors, and then if we could predict, we could create policies in place that could overcome these behavioral challenges. Now, in summary, in summarizing the whole thing, open burning is a harmful activity for us and for the human beings. It is very difficult to measure it at the extent of open burning because there is little data, and also it is an activity that is often done hiding in plain sight. But it also gives us an opportunity to use latest techniques like machine learning to measure the extent of open burning, understand the implications, and create policies that could combat this issue. After all, as the saying goes, what gets measured gets managed well. Thank you.
Thank you, Milan, for the informative presentation. A reminder to the audience to keep submitting your questions to the chat so that the speakers can answer to you. The 5th presentation will be introduced by Manalika Borgohayan from India, whose presentation title is Circular Economy of Biowaste, a case study on composting in Office of Accountant General, Odisha. Manalika is from the Indian Audit and Account Service, Government of India. Manalika, you may now take the stage.
Hello, can you hear me?
Yes, we can hear you properly.
Okay. Good afternoon, everyone. My name is Manalika Borgohain, and I'm a civil servant in the Government of India. Today, I'm going to present a case study on a waste disposal initiative that we implemented very successfully in our office using circular economy principles. I would like to thank ISWA for this opportunity and platform to present the initiative of our small office to an international audience. This is my office in the photo. So my office had been grappling with a waste management problem for a long time. The office canteen caters to a staff of 500 people, and the canteen and garden together generate around 50 kilograms of bio-waste daily. Earlier, the garbage collection agency would be paid according to weight of the garbage, and so every little scrap of garbage was valuable for them. But then the municipal rules changed, and the garbage agency is now paid a fixed rate per day. Since this new arrangement was not as profitable as the previous one, the agency became erratic and unreliable. Bio-waste from office canteen would be left outside the office for days without being collected, which was unhygienic, caused foul odor, and attracted stray dogs. This prompted us to look for possible solutions to the problem of bio-waste management. Now, one thing common about government offices around the world is that they are usually short-staffed and underfunded. So our primary concern was that the solution should be cost-effective, easy to implement, and sustainable over the long term. Being environmentally friendly was not our concern at this point. We just wanted to get rid of the garbage in the office with minimum effort and minimum cost. After carefully reviewing various options, we decided to adopt composting as the preferred solution to the waste management problem. Composting means converting organic matter into nutrient-rich soil through aerobic microbial activity. By composting the bio-waste in situ, we would produce nutrient-rich, humus-like compost for the office garden, which meant efficient management of available resources, something that government offices really love. Secondly, the office would be able to manage its canteen bio-waste without depending on an external garbage collection agency. Last but not the least, composting is a very low-cost, low-maintenance activity requiring negligible investment, which is again perfect for a government office. So as it turned out, the environmentally friendly option was also the most suitable solution for our needs. However, identifying a suitable solution was only half the battle. We also had to navigate a few challenges. One, coordination between canteen staff and garden staff was a big challenge, because both parties have their own duties and were not used to communicating with each other or working together. Two, there were misconceptions among the staff that composting was unhygienic and would cause foul odor in the office premises due to putrefaction. And the third challenge was that the staff would have to be motivated to segregate the waste each day, which was going to be an additional item of work for them. To tackle the second challenge and dispel the misconceptions and motivate staff, we hired a consultant for providing hand-holding support. We also arranged an exposure visit to a composting facility for the staff in collaboration with the consultant. The staff returned from the exposure visit feeling inspired and fully in support of the initiative. To overcome the coordination challenge, we created a timetable whereby the canteen waste and garden waste is brought to the compost site every day at a specified time. The canteen staff were given clear instructions that segregating the dry and wet waste from the kitchen was their duty, and the garden staff were given instructions that collecting dried leaves and turning and mixing the compost pile was their duty. So training and communication was very important because the success of the initiative depended on a bottom-up participatory approach with cooperation from the staff. You can see the shift here. Earlier, the unsegregated waste would be left out in the open and no one would take responsibility for its safe disposal. But once we adopted this composting initiative, the canteen and garden staff have taken on a leadership role in day-to-day management of bio-waste disposal in the spirit of our waste, our responsibility. You can also see in this photo that we constructed 6 concrete pits in our composting facility to cater to our bio-waste. These pits are constructed at a strategic location. They are placed under an old cycle shed to protect them from rain, and they are situated close to the canteen to minimize effort in transporting of bio-waste. Coming to the modus operandi, we explained to the staff that the success of composting depends on maintaining the correct ratio of carbon and nitrogen in the compost pile and regularly turning the compost pile for aeration. The garden staff is responsible for carbon, which comes mainly from browns such as dried leaves from the garden. Canteen staff is responsible for nitrogen, which comes from greens like vegetable peels from the canteen. To accelerate the process, a catalyst such as a waste decomposer culture, which is cow urine extract in our case, is sprayed on the compost pile. At the end of 3 months, we were ready to harvest the nutrient-rich compost. We are going to use this compost in our beautiful office garden, which the office is very proud of. This completes the loop of circular economy of bio-waste. You can see the transformation more clearly in these before and after photos. The advantage of composting is that the end product is ready to use in office gardens without requiring any stabilization. The thermophilic reaction due to aerobic activity ensures quick decomposition, destroys harmful pathogens, and produces odorless, non-toxic soil amendment. In the last 4-5 months, we have seen incredible impact from our initiative. Approximately 1,600 kgs or 1.78 tons of bio-waste has been successfully composted instead of being sent to landfills for unscientific disposal. Segregation means that dry waste can be reclaimed for recycling more easily. Dependency on erratic garbage collection agency has also reduced, and the stray dog menace has declined substantially. In situ availability of nutrient-rich compost will save the office approximately $600 annually on fertilizer and store-bought compost for the office garden. Finally, implementing this initiative successfully in a busy office is testimony to its replicability, frugality, and sustainability for large-scale adoption. The upscaling of staff is also a matter of pride and achievement for us. After the first batch of compost had matured sufficiently, we sent a sample to a government soil testing laboratory. To our great joy and excitement, the sample met all parameters tested for organic compost under India's solid waste management rules. So the fact that our compost is also organic is a nice bonus for us. This is our team. With our example, we hope to inspire more organizations to adopt this low-cost green initiative in their offices and to demonstrate that composting is not just for environmentalists or gardening enthusiasts. It has relevance even in formal settings like government offices as a viable solution to waste management concerns. Thank you.
Thank you, Manalika, for your informative presentation. Ladies and gentlemen, we have now reached the sixth presentation of this session. Please join me in welcoming Julia Andrade from Brazil. Julia will be presenting on the topic of evaluation of construction and demolition waste management in the Piracicaba, Capivari, Jundiaí river basins. Julia is from the School of Engineering of Sao Carlos at the University of Sao Paulo. Julia, please, the opportunity to speak is yours.
And thank you for the introduction. Can you see my screen?
Yes.
Okay. Hello, everyone. It's a pleasure to be here and present my work entitled Evaluation of Construction and Demolition Waste Management in the Piracicaba, Capivari, Jundiaí river basins. Constructions and demolition waste represent the largest part of the solid waste generated globally. In Europe alone, about 800 million tons of construction and demolition waste are generated annually. United States, about 600 million tons. And in Brazil, about 48 million tons of construction and demolition waste are collected in 2021, but this value may be much higher due to a portion that is not collected and ends up disposed in irregular places. The composition of construction and demolition waste may vary across countries due to environmental conditions and the construction practices. In Brazil, 70 to 80% of total construction and demolition waste volume has the potential to be recycled, but just 7.06 are recycled. Improper disposal of construction and demolition waste leads to increased environmental impacts, leads to depletion of natural resources through the extraction of natural aggregates, possible soil and water contamination, and increased land use. In order to change the current scenario and reach the goal established by the Brazilian government to recycle at least 25% until 2040, it's crucial to obtain information on the management of construction and demolition waste and thus promote actions that aim to reduce the generation, increase the rates of collection, and increase the demand for recycled aggregates, thus moving towards a more circular economy. So this work aims to provide an overview of construction and demolition waste management in the Piracicaba, Capivari, Jundiaí river basins. The basins are located in the southeastern region of Brazil, full or partially covering 76 municipalities with an approximate area of 15,000 320 square kilometers in a population of over 5 million inhabitants. Secondary data on the construction and demolition waste management in the river basins were obtained through municipal plans of solid waste management, which are documents that all municipalities in Brazil must develop and make available on websites of public institutions. The collected data was analyzed and the maps were generated using QGIS software version 3.32. With regards to generation, information was only found for 46 municipalities, with the annual emissions generated by them exceeding 2.5 million tons and the per capita generation of approximately 482 kilograms capita year. This value is more than twice the average per capita generation of construction and demolition waste in Brazil. This may be due to the higher gross domestic product in this region. With regard to collection, in 37.5% of the municipalities, constructions and demolition waste collection is exclusively carried out by private companies. In 34.7% of the municipalities, it's a combination of private companies and the public sector, with the large generation being responsible for hiring private companies for the collection of waste and the public sector being responsible for the collection of small generators and the construction and demolition waste disposed of in regular location. In 11.1% of the municipalities, the collection is solely conducted by public sector, and in the other municipalities, there is no information. With regard to the disposal of construction and demolition waste in the river basins, of the municipalities that their information, 53.2 dispose of it in an inadequate way, either disposing of it in unlicensed areas or reuse it without any type of criteria. This inadequate disposal can generate serious environmental impacts, either because of the hazardous amount of construction and demolition waste, like asbestos and paint, or because of the possible presence of the other types of waste. A more sustainable management of construction and demolition waste aims at is a recycling and incorporation into new materials and civil construction works. This study found that the recycled aggregates is producing only 32.2% of the municipalities. However, in some municipalities, only a part of the construction and demolition waste generated is sent to recycling plants. So it's possible to conclude that the construction and demolition waste generation obtained in this work for the Piracicaba, Capivari, Jundiaí river basins is much larger than the average per capita generation in Brazil. Most municipalities partially or completely dispose of construction and demolition waste inadequately, and the absence of public initiatives for the collection of the small generation can influence the regular disposal. So it's necessary to improve the local management of construction and demolition waste, obtain data from the generation and the characterization of construction and demolition waste, and encouraging recycling. Thank you, everyone. I leave my contact and the solid waste study and research group that I am part of, NEPER in Portuguese.
Thank you so much, Julia, for your excellent presentation. We have now reached the 7th presentation of this session. Please join me in welcoming Jerin Tasnim from USA. Jerin will be presenting on the topic of utilization of plastic waste as a sustainable solution for enhancing substrate pavement layer. Jerin is from Tower Engineering Solution, Texas. Jerin, you are welcome to start.
Hello, everyone. I hope you can hear me well and see my screen.
Yes.
Thank you. So, hello everyone. Welcome to my presentation on utilization of plastic waste as a sustainable solution for enhancing subgrade pavement layer. So, first we need to know what is subgrade and what problem it can cause. Subgrade is the bottommost layer or the prepared earth surface on which pavement is built. And the main function of subgrade is to provide the adequate support to all types of pavement. So if the subgrade soil is poor, it can directly cause damage to the surface of the road or embankment, such as road pavement defect or even the failure of the embankment, as you can see from this picture. So to fix the subgrade problem, several methods have been used, but they are very expensive. At the same time, plastic waste is now considered as one of the largest environmental threats. The whole world is producing 400 million tons of plastic every year, where USA alone is generating maximum plastic as a country, and the amount is 42 million tons. However, the recycling rate of the plastic has not kept pace, and it is not keeping pace with the increased production. In USA, only 4% of all plastic that has ever been produced has been recycled, 19% has been incinerated, and the rest 73% of the plastic has accumulated in landfills or dumped in the environment. So, to solve this problem, utilizing and turning most of the non-recyclable plastic waste into construction material is a potential solution. So this is our experimental program where we have tried to use the plastic as one of the subgrade material. So this slide shows the detailed experimental program for this research. First, we will collect the, we collected the soil and plastic, and then the soil was classified according to USCS classification system. Then USCS, the unconfined compressive strength test, permeability test, and soil test were performed for the soil alone and also for soil mixed with 2%, 3%, 4%, and 5% of shredded HDPE, PP, and PET. For these tests, we needed the optimum moisture content and maximum dry density. So for that, we also conducted the compaction test. This slide shows the compaction test result, where this blue line shows the control soil samples, moisture content, and maximum dry density. So for all the HDPE and PET mixed soil samples, the optimum moisture content and maximum dry density was less than the control soil sample, which was required for the construction of lightweight pavement. So from these tests, we got the optimum moisture content and maximum dry density for all the plastic mixed soil and also for control soil. So if we look at the unconfined compressive strength test result, we can see that the soil strength was significantly increased by the increase of plastic. For HDPE mixed samples, the highest strength was observed 88% for 4% of HDPE mix. For PET mix, it was 75%, and for PP mix, it was 57%. So here we can see that strength was at first increased with the increase of plastic content, but after reaching an optimum point, it started to decrease. This might be because the greater tensile strength of plastic contributes to the formation of soil and sustain greater load. But mixing too much plastic makes the soil slippery and lose cohesion. So the UC strength start to decrease after an optimum point. This slide shows the hydraulic conductivity test results. So hydraulic conductivity is the measure of permeability, which means how much water can drain in the soil. So the greater hydraulic conductivity we get, the better result we can observe. So we can see from this slide that the hydraulic conductivity of soil is increased with the increase of plastic content, which is good for drainage. And this slide finally shows us the soil test result. So for our control soil sample, we got 2% of free soil index. But when we started to mix the plastic with the soil, the improvement was noticed, which is very significant. And for soil mixed with 5% of plastic, as you can see from this chart, that the improvement was 73%, which is very important for soil not to swell. And that brings us to the summary of this research. So we conducted our research in a high plastic clay type of soil. And if we looked at the usage test result, we can see that the initially strength was increased with the increase of plastic, but after an optimum point, strength started to decrease. And the best result was observed for 4% of HDP. Similarly, for hydraulic conductivity test result, we observed that the better result was observed when we are adding more plastic. And for swell test, the swelling index started to decrease very significantly with the increase of plastic content. So that brings us to the end of the presentation. Thank you so much for your time and attention, everyone. If you have any question, you can email me. Thank you.
Thank you, Jerin, for your insightful presentation. The eighth presentation will be introduced by Ashpreet Kaur from USA, whose presentation title is Campus Zero Waste Program Toward a Better Understanding of Zero Waste Program Success. Ashpreet is from the School of Natural Resource and Environment, University of Florida. Ashpreet, the floor is yours.
Thank you so much for introducing me. I know it's a long day, so I'll try to keep my presentation short. But today, as you all know, I'll jump straight into the presentation. So as you all know, climate change is one of the most researched topic these days, but I would like to bring your attention to waste crisis, which is as important and also part of climate mitigation. So US alone generated 292.4 million tons of, just a second, let me see if it's moving. Okay, got it. So US alone generated 292.4 million tons of municipal solid waste in the year 2018, which has a lot of useful materials that go to the landfills. And if we can divert all this waste from the landfill, especially the food waste, we are helping divert major greenhouse gases such as methane from landfills. So how can we do that? The answer is by adopting circular economy, where all the materials are kept in use in one form or the other, but by adopting the practices that reduce wastage of materials. So zero waste is built on the foundation of circular economy and recently was internationally recognized by the UN for its importance. And now we celebrate March 30th as International Zero Waste Day. So you may ask, is zero waste possible? And a simple answer is no, because zero waste does not mean 100% waste reduction. A technical definition of it is reducing 90% or more of the waste from landfills and incinerators. And of course, there is some waste, such as hazardous waste, that must go to the landfills or incinerated. Zero waste has a hierarchy of material use, where the first three steps is what researchers are trying to study lately as to how to redesign existing systems to reduce waste generation and how to reuse the materials generated as waste. This can look like changing the plastic in the mouse to wood to avoid plastic waste, or implementing policies of waste reduction, such as mandatory recycling or composting. So in my research, I'm focusing on higher education institutions and looking at the factors that make a zero waste program or waste reduction and minimization program successful in these institutions. First, there is very limited academic literature in the field of zero waste, and the existing literature on zero waste is mostly focusing on zero waste cities. Additionally, the existing sustainability frameworks such as Global Reporting Initiative and even the SDGs tell nothing about how to reach the 2030 goal of reducing waste. So this is a problem my study is trying to answer by using a mixed method analysis. I use statistical analysis as well as qualitative interviews to find what factors, internal and external to an institution, affect the success of zero waste programs, and what are some of the barriers and opportunities to achieving successful zero waste programs. So for this as a statistical analysis, the data was collected from STARS, which is an international organization where the higher education institutions can report their sustainability data. The success of the zero waste programs was measured by scores on the waste diversion and minimization section in this STARS framework, ranging from 0 to 8, the scores, and it includes activities like recycling, reuse, donating, refurbishing, along with our usual composting, recycling, and incineration. For quantitative analysis, I used backward stepwise elimination regression, which provides a best subset of most influential variables. So the results showed that institutions in the west of the US, west zone of the US, such as California, Washington, and the doctoral level institutions and public institutions have higher scores than others. And it's as based on literature, it's mainly due to more funding availability to these institutions. Then institutions which have sustainable procurement, also known as sustainable purchasing policies, have higher scores than others. Institutions with availability of sustainability training for staff members also had higher scores. But the most important variable that had the most influence on the waste diversion and minimization score was for institutions to be a member of state sustainability networks. So being a member of such networks provides higher education institutions an opportunity for professional development and sharing the best practices among, which gives them a chance to improve existing practices to efficiently reduce waste in their institutions. So next, I conducted a Delphi survey, which is a 3-round consensus-based survey with the zero waste experts of higher education institutions or people who handle the waste diversion and minimization programs in HEIs. I asked them to share and then rate the barriers and opportunities in reaching successful zero waste programs. At the end of the 3 rounds, 7 barrier statements and 11 opportunity statements met the consensus of 70% and were included in the study for further discussion. I also invited them for semi-structured interviews to get more knowledge about the top 5 barriers and opportunities. So based on the survey, the top 5 opportunities are having a zero-waste policy included in institution's strategic plan, which is the highest guiding document of an institution. Having a good relation with the stakeholders inside and outside the institution, collaborating with local waste organizations and reuse centers, having sustainable procurement policies, as shown by the quantitative data results also, and presence of active student bodies on the college campus. And the barriers are lack of compliance with recycling, which is mainly due to lack of education and awareness, absence of engagement in waste reduction activities, lack of full-time employees, as well as shortage of ground labor, which is mostly due to the labor market in the US and the low-paying jobs in this industry. So this is just an example of what my interviews look like. So I did selective coding of these interviews and thematically analyzed them to understand the experiences of interviewees. So here are just the examples that the interviewers shared with me. So combining the results from both the methods, the top 3 important results are having a centralized and mandatory sustainable procurement policies, as well as hiring someone to keep check on what is being purchased and coming into the institutions. It's important because currently the institutions are buying whatever they want without any check. So that person can actually ask, is there questions like, is there a need for it? Is the material sustainable? So all the unnecessary purchases can be avoided. Second is providing continual education and outreach to students and training to the staff regarding best practices of waste management and what is the importance of zero waste in general. Because the campus is very diverse and there are many students and even employees coming from various parts of the world, and they might not know much about recycling practices in the US. So the awareness can help to avoid the contamination of the waste streams and also inculcate an environmental friendly behavior and pro-environmental behavior in these individuals. And the third is including zero waste policy in institution strategic plan. As I told, the strategic plan is usually the highest guiding document of an institution. So when you include it there, it helps you to hold administration accountable and also provides the sustainability department an opportunity to hire more people, as well as make a case to demand more funds to support the zero waste programs. So this study does not aim to generalize the findings, but the findings may be useful for institutions that aim at becoming zero waste. It also aims to improve the STARS, the sustainability framework that I use in my study, and other similar sustainability frameworks by providing the recommendations based on the research. By adding the variables such as improving their tracking system by including questions on infrastructure, on policies, like whether they have the mandatory policies or not, which is currently missing in their framework. So this research is actually first of its kind to focus on the factors that can help higher education institutions to improve their zero waste programs, thus adding to the current limited literature on zero waste. So that is it with my presentation. If you have any questions, I would love to answer them. Thanks so much.
Thank you, Ashpreet, for sharing your expertise and insights in this topic. Now, ladies and gentlemen, we have come to the ninth and the last presentation of this session. Let's welcome Carlota Comalas from Spain, whose presentation title is ISWA, a solution for waste collection and environmental awareness in middle-income countries. Carlota is from Polytechnic University of Catalonia. Carlota, feel free to share your ideas. Carlota, we can't hear you. So there must be something. Yeah, we can see your screen, but we can't hear you. Still nothing. Can you please check your audio? Still we can't hear anything.
Carlota, maybe you can try to join again.
We are having some technical issues, so let's wait for some time for Carlota to rejoin. So don't worry, technical issues are all part of the online event experience. So now let's wait for some time, and thank you all for your understanding. Carlota, what about now? Still, we can't hear anything. Do you have any headphone? Can you please unplug the headphone and plug it again? Hello, Carlota. So we are really sorry, but it seems like we are experiencing some technical issues. So don't worry about that. So that's fine. We'll make sure to share this presentation and a recorded version of this presentation in the conference. So you won't miss out of any of the exciting content. So Carlota, it would be great if you can record your conversation and share it to us. We'll add this recorded video in the final recorded conference video. Okay. So I'm really sorry, Carlota. So yeah, I guess we can move forward. So I really appreciate everyone who submitted a question to all of our brilliant speakers. I'm impressed with the high level contribution. It's gonna make the evaluation really difficult. I would like to remind you that these presentations were part of a competition, and we will be selecting the 5 best presenters from the conference. We will be announcing the winners on our website, and we will also be publishing all the presenters' abstracts in the conference book, which will also be available on the website soon. Please note that the recording will also be shared with you. Now I leave the floor to Dr. Hania Jalalipur, Vice Chair of ISWA YPG, who is going to moderate the special session to highlight the main activities and the ongoing activities of the YPG working groups. Hania, go ahead, and the floor is open for you.
Thank you, Aziz. So there won't be a pause or. Okay, I will share my screen. Do you see my presentation?
Yes, Hania, I can see.
Okay. So, hello, everyone. My name is Hania Jalalipur. I'm a postdoc researcher at the University of Rostock, Germany. I'm the vice chair of the Young Professional Group and also the chair of the regional chapter for Germany. Today, I will explain a little bit more and give information for those who are new about the ISWA and the Young Professional Group. So ISWA is the international network of professionals from around the world whose mission is to develop and promote the sustainable solid waste management and the transition toward the circular economy. The headquarters of ISWA is currently in Rotterdam, Netherlands, and the structure of the ISWA you can see in this slide. And ISWA Young Professional is an independent initiative and a special group of ISWA. About the Young Professional Group, I would say if you want to ask me an official definition, it's that the mission of the YPGs is to make a global connection about young people under 36 who has passion about the solid waste management, and the aim is to share knowledge, ideas to improve waste and resource management. But if you want to ask me like my personal experience, I would say that the Young Professional Group is for me a support group for my professional life. So whether you want to have to see the new job opportunities, to have mentorship, or to want to create, looking for partners to write new projects, or to know best experience and extend your knowledge, or simply if you want to have a nice chat with a like-minded person, this is where you can find a very good possibility in the Young Professional Group. Our activity is divided in several working groups. online discussion group, marketing communication, mentorship, education, research and innovation, and local networks. So today's conference, for example, is part of the research and innovation group. Dr. Amani Malouf is the chair of the research and innovation group, and Dr. Azizul Islam is the vice chair, and they are yearly plan this online conference. One of their main activity last year was also writing and developing a paper with cooperation of the several young professionals, and the topic was the circular economy in the plastic waste. And we will hear more of the other working groups' activity and aims today. That's why I would like to invite Ashprit. The first working group is the online discussion that we will hear more about it. So Ashprit, please, if you hear me, if you can continue.
Yes.
So thank you. The floor is yours. Please give us some more information about the interesting activity of the online discussion and meeting groups. Thank you.
Sure. Should I share my screen, honey?
Yeah, I will. Just in a moment, I will stop. If you can, okay, stop sharing. Yeah. Now the floor is yours.
Let me share my screen. Okay. Thank you so much, honey. And all the participants, thank you so much that you have joined us. And on behalf of all the ISWA groups, I just want to say that this is a really good platform that you can bring your leadership skills or any information that you have. You will be provided the opportunity to shine, and your opinions are heard in this group. So I would really encourage to join any of the working groups that really interests you. So just a little bit about our working group. We are the online discussion and meetings working group. So she's Aslam. She also presented today. She is the chair of our working group, and I'm the vice chair. So our aim is to conduct educational online webinars and discussions on various solid waste related topics. And we really invite anyone who really wants to share their opinion. We invite experts from the industry from all over the world. But if you think that this is a platform that you really want to speak at, we really invite you to come speak at our event. Any information that you want to share, any exciting innovation that you have done recently. So our platform provides all the opportunity to do such things. We also provide trainings, and I'll talk more about that in the coming slide. We have provided certificates for some of the trainings, and in addition to that, we also support the other working groups that ISWA has. So it's really very interconnected with each other. So we have conducted workshops since 2016. We have been doing workshops, but I'll just talk about the past workshops that we did this year. So the first one was we did a waste generation and characterization training course. I think we received tremendous interest from the participants. Like, as you can see, there were 681 registration, 170 participants joined, and it was a 2-day course. So we had speakers from Germany, and I'm blanking on some other from other countries, but they provided the training course, the training on this course. So we provided the participants to complete a quiz, and once they successfully completed it, they were provided the certificates. And we're hopeful that these trainings and the certificates that we give, that they really help our participants. So if you want to access any of the course materials, so we have the live recording available on our website, and even the past webinars are there. So this is the link if you want to go and check out the events and the recordings that we have done. The second one was the webinar on life cycle assessment. So in this assessment, we had 2 speakers, one from Germany and one from the US. So they talked about basics of LCA, what's the importance and what's the methodology, the software and the tools that you could use to do LCA. So Again, the recording for this is also available on our website, and we are very active on LinkedIn. We always post our webinars on our LinkedIn group as well. So yeah, just in the summary, like if you're passionate to learn more what we are doing, or if you want to work on a leadership role or educate the audience about innovation or any new information that you have, please feel free to join our group. And this is a QR code that you can like scan, and you can visit the website right now. So yeah, there's possibility of some perks, like sometimes we get free tickets to ISWA Congress. So if that interests you, maybe you can join any of the leadership groups. So yeah, if you want to contact us, our email is odmswat@gmail.com. Thank you so much.
Thank you, Ashpreet. Thank you for all the efforts and the interesting webinars and courses that you developed last year. So the next working group that we will hear today is the education working group, and they all have a very interesting event upcoming that will launch in this call. That is why I want to leave the floor to Kartik. Hi, Kartik.
Hi, Hania. Hello.
And the floor is all yours.
Thank you. Thank you so much. Just please give me a heads up if my screen is visible, and then I'll quickly start.
All set and perfect.
Perfect. I won't be taking much of our time and try to keep it really short because we have a very big announcement to make today at the end of this presentation. But before that, I would just like to introduce you to the working group that I'm part of, which is on awareness and education. And the work that we basically do is to promote the principles of circular economy in 3 Rs by doing awareness activities, campaigns, and also developing a knowledge base on awareness and education materials. I'll give you a quick highlight of few activities that we have done. So on our website of ISWA YPG, we have a resource platform there. This resource platform is a place where we are putting up a lot of case studies, discussions, and activities which basically are concerning the awareness and education domain and could be replicable and be used. And today, looking at the interesting presentations and especially the community level participations that you showcase, I think it would be really great if anyone would like to share your case studies with us. We can also put it on our platform here. 2 years ago, we basically did a call for best practices. The focus of this call was waste education in schools. We received multiple responses, and we selected 21 best case studies from that, and we prepared fact sheets out of it. This was done in collaboration with UN Habitat, and these fact sheets are also something which are showing some global practices on waste education in schools, which are available online and on our resource platform. And as a follow-up, what we did was some regional events focusing in Africa region, Latin America, and Asia, where utilizing these best practices that we found, we kickstarted some discussions among the local stakeholders that what are the best way of approaching the education and awareness domain in the waste management space. And lastly, we are also working on education program for school. So this is one of our pet program that we've been developing. It's a 5-module course which has been currently translated into Spanish language. We are a small team of independent people who are volunteering under this group, and what we do as working members is that we participate in monthly meetings. So we give an hour a month daily to hour a month to it. We organize ourselves in independent activities and lead them, and that basically helps us to learn more about the whole domain of awareness and education. And I would be happy to welcome any one of you who's interested to participate or initiate new activity in our working group. We'll be happy to have you here. So one of the future activity that we have that our group is supporting now is the YPG flagship event. And the main objective for the flagship event this year is basically to raise the awareness on solid waste management as an issue in communities, and also bring forward some good campaigns, education programs that have created some good impact for the society, are replicable and the outreach of them can basically create a multiple impact of inspiring other people too. So without wasting the time, I'll come to this big news, which is our flagship event. So Hania, will you give us a count of 1, 2, 3 here?
Yeah, sure. Thank you for the interesting launching of event. So 1, 2, 3, Karthik, go.
And here we go. So today we are launching our call for best practices to create zero waste communities. This is going to be the flagship event for 23-24 of ISWA YPG. We are inviting the submissions on best practices that have been implemented in communities to create zero waste communities and have focus on awareness and education. And the best practice which would be selected would be given a prize money of 1,000 euros, and there would be some other best practices which would also be awarded through ISWA membership. So the deadline is September 30th, so we do have 2 months. Participants who gave presentations today or who are actively working in the communities, please come forward, spread the word about it. We'll be happy to receive your submissions here. Just a short timeline how we are organizing our flagship event here. So we are launching the call today. And the deadline for submissions would be September 2023. By November, we would be announcing the winners, and then all the submissions which are credible enough and are selected by our evaluation team would be converted into fact sheets. These fact sheets would be getting the visibility on UN Habitat's Waste Free Cities programs website and ISWA website. They would be part of our knowledge platform. And based on this fact sheets and the submissions that we received, we'll be doing some regional focus webinars to promote the overall cause of education and awareness in the waste management space. So I look forward to your enthusiastic participation in it. And over to you, Hania.
Thank you very much, Karthik. Thanks for this interesting and amazing news. So who are today present at this conference had the chance not only to hear those many interesting presentation, but also having this exciting news. I hope that you will be ready and submitting some case study to this initiative. So our next, I will again share my screen. The next working group will be regional networks. Unfortunately, the chair and vice chair couldn't participate today. The chair is Adeline, and the vice chair is Lorena from Brazil. Regional chapter is one of our interesting working groups. And this is basically, there's a concept in young professional group that in a country level, if you have 3 young professional members, they can create a local group and a local community of young professionals, and you can address more local issues and work more locally. That is why this is a very interesting, and to be part of a local chapter, you won't need to be like an official member of the young professional group. As I said, there is only the need for 3 official members to create a local chapter. So, so far, okay, let me put it on there. So far, we have various number of the country level local chapters, Colombia, Brazil, in all the continent, and as you see, Spain, Nepal, India, Malaysia, Pakistan, and soon the South Africa, Norway, and Singapore will come. I will show you some activity of the local chapters. This is the local activity of the Colombia chapter last year. They had a very interesting face-to-face event with the sponsoring of the Tetra Pak Colombia. It was like a workshop, and they had also morning cafe with some expert to talk with them and put them in video in the YouTube so that the people can use it. From my chapter, we had also online get-together, and we had also in the in the context of a scientific conference, we had the chance to plan a site visit from an old landfill in Hamburg, and that is also our lunch in the IFAD Munich that we could see, meet, and talk and have some workshop. So that is how basically a local chapter works. You can address more and you can be more local events and communicate and go and have a more in-person events. But after the corona, we faced several problems and challenges in our local chapters. Some countries didn't have membership, or some although there were some individuals who want to be active. That is why we came with this idea that to merge some of these local chapters to a regional chapters and provide the opportunities to all the young professionals who wants to be active and who wants benefit from the young professional group. The first regional group that is to be launched is the African regional group, and I'm so happy that this is the second launch of today and the second exciting news of this year. So I will leave the room to Mark. He is the chair of the regional working group for Africa. Mark, please give us more information about the African regional chapter. I stop my sharing.
Thanks, Hania. Let me just share my screen. Can you confirm you can see my screen?
Yes, I see.
Thank you. So yes, thanks, Hania. We're excited to announce that the African Regional Chapter of YPG has been started. So just a basic outline of why we wanted the African Regional Chapter. I think in Africa, the waste industry is mostly dominated by older generations, and there's very few opportunities for young professionals to network and meet each other, especially across borders within Africa. It's easier to meet people in Europe than to meet other African young professionals. And so it was a great opportunity for this YPG to have an African chapter where we can actually start to meet and work together with other young professionals from Africa. So we have 4 founding members for the African chapter at the moment, and 3 of us are from South Africa, and then Zipporah is actually based in Germany, but she is from Ghana. And we're hoping that we can get a lot more members to join from other parts of Africa. So there are a few upcoming events that we already have planned for the young professional group. There's the ICER Africa taking place in Ghana in September. And then we also will have the workshop and meetup at the Landfill and Waste Treatment Conference, which is happening in Cape Town in South Africa in October. And then we also are planning potential future online events where we can actually network and meet each other and get to know each other. So basically, who can join this young professional regional chapter? We've said it's anyone under the age of 36, and it's waste professionals from Africa. So this can be people who are working in Africa, or it can be people who originate from Africa. And for this regional chapter, we have said that it's for members of ISWA or any of the national waste management associations to ensure that we maintain it as a professional group. And so if you are interested, if you fall into those categories, please scan the QR code and join our group. We'd love to have you. Thank you very much, Hania. Back to you.
Thank you, Mark. Thank you for the interesting initiative. So please, everyone, consider that if you want to be a member of the young professional group, you can find all the information on our website. And you can directly email the working group, the people who you want to be joined. For example, if you want to be part of like African chapter, you can go to the website and find this information there and email them and fill out the form. By any other question, feel free to contact me. You can find me on LinkedIn, and my email address is also on the website. You can directly write an email to me and I will provide you information. So we are coming to our end of the ceremony, and we will have the closing session. So I will invite our speaker for the closing session, Brenda Hanley. I'm honored that last year I had this opportunity to go to Texas, actually in the summer, and know Brenda myself. I'm very excited to see you and meet you today again. Please, Brenda, I leave the floor to you so that other people can also enjoy from your experience and point of view. Thank you.
Thank you, Hani. Before you start, so small introduction about Brenda. Brenda is a director of solid waste at the city of Lubbock, and she's a registered professional engineer with about 30 years of experience in civil engineering, with more than 25 years exclusively working on solid waste management. Brenda, we are honored to have you here today, and we are eagerly awaiting for your enlightening presentation. The stage is now yours to share your inspiring and motivational speech. Thank you, Brenda. The floor is yours.
Thank you, Imani. It's so wonderful to have been invited to be here with y'all today. This is great to see so many familiar faces. As Hania said, she came to Texas and I'm one of the speakers. So I am a founding member of the Solid Waste Institute for Sustainability out of the University of Texas at Arlington. It is a group that is a research center out of the University of Texas at Arlington, but really the focus is that I've had an opportunity to be a part of is teaching the winter school for ISWA for the last 6-7 years now. So I started with them, and I will continue to do that as long as they will invite me to be a part of it, because it's one of the best parts of my year and my career is I get to spend 2 weeks with young professionals like you talking about my career journey in solid waste, and we talk about some of the deep dive and some of the technical things and where we're at today and where we see the industry going. It is maybe I get to impart a little bit of knowledge, but for me, I get so much back from the group. And just the little bit of time I've spent with you this morning, or this morning for me, it's very early in Texas right now for a Saturday morning, and I'm excited to be starting off my day this way. But I get so much more out of the young professionals than I probably give to you. This is a terrific industry to be a part of. And it took me a few years as I started my career before I actually got started in the solid waste industry. And once I got into it, I knew it was the place for me. So I am a registered professional engineer in the state of Texas. I am a civil engineer. And as we know, civil engineering covers a variety of different industries, technologies, specific fields. And what I found fascinating about the very first landfill design I did, and expansion on that, is it tapped into every bit of my civil engineering practice. So I got to do a little transportation, I got to do a little water and wastewater, I got to do some geotechnical work, the environmental side, obviously. And so it's really exciting. You know, it was very exciting as I got started on this. And as I have spent all of these years in the industry, I've seen the business change, and it is evolving and growing. And what we used to do, you know, Mark, I'm one of those old professionals, but I'm very anxious to let the young professionals in. It's your turn to shine. But when started, the industry was very different than it is today. And what I think is so exciting about where you're at in your careers, and as you continue to go forward at this point in the solid waste industry, is that there is so many changes that are happening in the business right now. You know, I consider myself a solid waste professional, and we're talking about zero waste. And that seems a little contradictory. I think to me, it's kind of akin to folks that are worried about AI and robots taking away their positions to work. And I don't think that's the case. I think what it is an expansion of an industry that we have worked on. It is an opportunity to develop new and exciting techniques and technologies, and it just gives us an opportunity to grow and develop as professionals. So what I challenge each of you to do, and I do this every time I have an opportunity to talk to young professionals, is don't be shy. Please don't pass up opportunities to engage. The fact that you're involved in the young professional group with ISWA, and for me to watch where this group has gone over the last 6 years has been amazing. Don't hesitate to get involved. Don't hesitate to, many of us old professionals like myself are very anxious to talk with you and share with you and engage with you and learn more from you and share what we can to get you on a path to get some stuff accomplished in our industry. So take your opportunities to involve, push the industry, which all of you are doing. You've got all these great new ideas, new technologies, new research that is just fascinating to sit and observe and learn from each of you. It's a nice part of my career to be able to get back from you and continue to evolve as a professional and learn from each of you. So don't shy away from the business. I find the solid waste industry to be incredibly fascinating. I find it to be incredibly challenging. I find it to be never ending. So I know you've got as many years ahead of you as I've had in the industry. What I know is, as a human, we continue to make waste, and we as professionals are challenged to find ways to manage that waste. There seems to be less involvement on the upstream side of this, of how to limit the production of some of these materials, and it continues to fall on us to try to find ways to appropriately manage and address this waste once it's created. I want to encourage you to look at ways to cross those bridges as we continue to evolve and work with other industries, producers, manufacturers, people that are creating these waste, packaging, and see if there's ways that we can work with them on the upstream side of this to try to limit some of the waste that we're dealing with on the downstream side of this. And I think that another part of the industry that I find so fascinating is that you are always dealing with people, and people make this job rewarding, but it also makes it challenging. Because part of, and it was great to see, I caught part of the educational part of this, the working group working on education and outreach. And I've said this before, this is one of the most challenging times to work with people to market and educate because there are so many different ways. Many of you you get all of your information from either your phone or your computer. And there are still people that get all of their information from a newspaper. I just had the fortune of spending a week with my parents, not necessarily intentionally, but I got a pleasure, and they're reading the newspaper. And so you've got that generation of folks that are still around that are reading things from their newspaper, to people that are getting all of their information and digesting everything from a cell phone. And it's hard to market and educate across all of those media effectively and all of those different generations, because all of us receive information differently. So working with, as an engineer, I wasn't educated and trained on how to, educate and market to people. So it's been one of these evolving skills that we've had to create and come up with to find ways to communicate needs and expectations on individuals. So I think as we continue to move forward, that will be one of your biggest challenges, is changing behaviors and habits of people that you will encounter in your communities and your countries at large. So I just want to remind you that this is an amazing industry. ISWA has a ton of resources available. And many of you will know that my alliance in history has been with SWANA. I've just finished my past presidency, and I've spent over 25 years in the business and as a member of that organization. But I've had an opportunity to go to some world congresses for ISWA, to teach again at the Winter School. And it's exciting to see the collective that ISWA does by bringing all these different countries and all these different parts of the world together to work on solid waste solutions and waste management solutions as we go forward. So I just wanted to say thank you for your interest, dedicating part of your weekend to learning and engaging with other young professionals. Thank you for having me here for just a couple of minutes. I know I've watched Amani since she came to Texas and was part of the Winter School, and she's doing amazing, great things. And there's other people here. So I know that our future in the industry looks very, very bright. Y'all are exceptional professionals, and I look forward to learning and working with you as I go forward in my career at the twilight and the sunset of my career, as each of you are embarking on your career in this journey. So thank you.
Thank you, Brenda, for delivering such an inspiring and motivational speech. Your insights and experiences have truly enriched our conference. It was an absolute pleasure to have you with us today, and we greatly appreciate the knowledge and expertise you shared with the audience. You have constantly been an inspiring leader in waste management, and your remarkable work with the communities has laid the foundation for sustainable waste management practices. Thank you so much, Brenda. Now we arrive to the closing session of the conference. I want to express my sincere gratitude for your active engagement in the 6th ISWA YPG online conference titled Our Waste, Our Responsibility Towards Zero Waste, Innovation and Challenges in Sustainable Development. It has been an intense and captivating event with our esteemed speakers delivering insightful messages. On behalf of the organizing committee, I extend my deepest appreciation to our exceptional speakers, presenters, and fellow YPG members for their invaluable contributions, which made this conference a success. Additionally, a big thank you goes to our global audience, whose presence and engagement have truly made this event a global gathering. I also want to take this opportunity to extend my deepest gratitude to the individuals who have played a crucial role in making this conference a real success. First, I want to thank Aziz for his dedication and commitment. It has been an absolute pleasure collaborating with you, and your contributions have been invaluable. A special thank you goes to Hani for coordinating the special session and learning more about the exciting news and YPG activities. I would like to acknowledge Roland and Noor, who were instrumental in developing the conference marketing materials and website. Ines, your hard work in the development of the conference book has been truly impressive and has added a professional touch to the event. A big thank you to Chantal for efficiently handling all the logistics and ensuring that everything runs smoothly throughout the conference. Last but not least, I want to express my gratitude to Senila for her invaluable support in the evaluation process. Also, a big thank you to Kartik for launching the YPG flagship project called for the best practices for creating zero waste communities with the support of Wastewise Cities UN Habitat. Stay tuned on the YPG platform for more updates and information about this exciting initiative. With this, we conclude the 6th ISWA YPG online conference. I hope you found the conference informative, inspiring, and enjoyable. Thank you all for being part of this exceptional event, and we hope to welcome you back next year for another remarkable conference. Don't miss the opportunity to join us at the ISWA YPG and the Research and Innovation Working Group, where Aziz and I are sharing the group. Stay tuned to the conference website for the announcement of the competition winners, the conference book, and the recording of the conference sessions. Before we end, I invite all participants to run on their cameras for a final group photo, and we look forward to meeting you all in person at the upcoming ISWA World Congress in Oman. Thank you, everyone. Chantal, if you can help with the screenshot?
Yes, I will.
Thank you.
Is everybody ready?
Yes, ready.
Okay. Hold on. 1, 2, 3. Yeah, one more. Can I take one more?
Yes, sure.
Yeah. One more. 1, 2, 3. Okay.
Thank
Here I
you,
go.
Chantal. Thank you, everyone.
Thank you, everyone. Thank you, Amani. Thank you, Aziz.
Thank you, everyone.
Thank you.
Thank you.